So, hello students, how are you? So, today will be our day 2. So, please join the class. We will start in a minute. So far, we have covered the mole concept, the percentage composition. Today, our focus will be on, say, your limiting reagent, first of all. So, this is the one topic that we have not covered so far. And one more topic where questions are asked sometimes, like Dalton's atomic theory, right? So, there one question was asked in 2023. So, for that will also be covered today. So just join the class quickly so we can start it. Okay, so today we will be having sufficient time. Okay, 1 hour 20 minutes. So we will cover the theory and 10 questions, right? Don't worry if you are upset about the yesterday's class for being too small. We will extend it to 1 hour and 20 minutes. Okay, so shall we start the class? So I will wait up till 4:03, then we will start with the class. So this is our day 2 of the some basic concepts of chemistry, right? So we have covered the mole concept. We have already covered the part of this chapter. Okay, there will be PYQs for the question part, and questions will be from both the part of the theory, right? Okay, so I think the time has already been stuck to 4:03. So from this chapter we will be covering. So this is our disclaimer first of all. So we will be covering chemical equation and stoichiometry. So this is the first thing that we will see. Then after we will move on to limiting reagents. Now questions are asked from here. You have seen what is limiting reagent if you have done the preparations and all. I will give a quick overview of that. Then we will move on to Dalton's atomic theory. Okay, there are 5 postulates and all of them are very easy to understand, and if a question is from there you can easily attempt it. Lastly, we have law of chemical combinations, right? Apart from these 4, we have one more topic which is equivalent weight. So some of you were asking what is equivalent weight. So we will turn to that topic also for a minute so that you can get an idea of how do we calculate the normality. So for normality, you need this equivalent weight, right? So today I will give you the formula to calculate this equivalent weight as well. And this thing is very important and very helpful in your calculations, right? So these are the 4 topics. So we will begin with the first one, which is chemical equations and stoichiometry. Now, to understand what is stoichiometry and chemical calculation, we first have to know what is stoichiometric coefficient. Now, if you are talking about a balanced chemical equation, then there we have a stoichiometric coefficient which is present before the equation, so that the number of moles of reactants and number of the moles of products are equal. So if you take an example for the production of water, so we have 1 mole of water hydrogen reacting with half moles of this, say, oxygen, to give us 1 mole of water. So here you can see that we have a coefficient for hydrogen as 1, coefficient of oxygen as half, and coefficient of water as 1. So basically these are the stoichiometric coefficient which is helping us to balance the number of moles of reactants and products. You know it very well. Now what is the outcome of this chemical equation? It helps us to determine 2 things, 2 very important things. First is qualitative analysis, which tells us that what are the atoms which are being participating in the reaction, and the second one is what is the amount or what is the count of that atom which is participating in that reaction. Now moving on to further, we can now define stoichiometry. So stoichiometry is something which helps us to calculate the masses of the reactants and products. So from stoichiometric coefficient, you know the moles, and from that mole you can calculate the mass. Now we have seen how your mole concept is being diversified and used in 3 concepts. What are those? First of all, you can calculate the number of moles, right? How you can calculate it? If you have the volume of the gas, right? For that you will use 22.4 liter. Remember in the previous class we have talked about this. So basically if you have a given mass, then you divide it by a given volume, if you divide by 22.4, you can get your number of moles. Then you have your second important formula, which is given mass by molar mass. And the third important formula was the given number of particles by the Avogadro number. So these were the three formulas. So if you know the number of moles, you can calculate the masses also. Okay. Moving on further, numerals are used to balance a chemical equations, and these numerals are known as stoichiometric coefficient. We know that. We have talked about an example. Now moving on further, for stoichiometric calculation, the mole relationship between different reactants and products are required because it helps us to build a relationship between mass and mass, mass and volume, volume and volume for reactants and products. So if you know the mole, you can calculate that how much mass is being reacting or how much volume is reacting if the given gas is, if the given substance is gas as STP. Okay. Now moving on to the next one, which is reaction yield. Now there are questions from reaction yield in your practical chemistry. In analytical chemistry, you will get questions for calculating the reaction yield, and it has a very simple formula. Let's see. So for understanding that, before you should know what is limiting reagent. So just note it down. What is limiting reagent? It is the substance which is completely consumed in a reaction. Okay. Suppose you know that 1 mole of hydrogen will react with half mole of oxygen. Right. Now instead of that 1 mole of hydrogen, you are taking half mole of hydrogen. What will happen? Your half mole of hydrogen will be consumed, right? Because the oxygen is present in excess amount. As a result of that, your hydrogen will be consumed wholly and your oxygen will be left in the reaction mixture. So basically, here the hydrogen is acting as a limiting reagent. So the one which is present in less amount, okay? The one which is present in less amount or which is stopping your reaction is known as the limiting reagent. Got it? Moving on further, we have the formula of reaction yield. It is very simple, which is given as actual yield by theoretical yield into 100. So suppose you do a reaction and you expect that you should get 4 gram of any substance. But instead of that, you are getting only 2 gram of that substance. So 2 gram will be your actual yield. Theoretical yield which you have expected was 4 gram. Then 2 by 4 into 100 gives you your reaction yield. Okay, so this is basically used to know the efficiency of a given reaction, that how much your reaction was efficient to get your required product. Okay. Moving on to further. So in stoichiometry, if the quantities of 2 or more reactants are given, the amount of product formed depend on the limiting reagent. Of course, so suppose one is present in less amount, then that will decide how much the reaction will proceed. Okay. That will decide how much product will be formed. So all of your reaction, the quantity, which is the product quantity, is dependent upon the limiting reagent. Okay. Moving on to further. Next we have Dalton's atomic theory and its key principles. So John Dalton in 1808 proposed a significant idea about atoms. He stated that all matter is composed of tiny particles called atoms. These atoms are extremely small and are indivisible. They are the basic building blocks of everything. Okay. So what are the main postulate of this theory? The main postulate of this theory are as follows. First one, atoms were considered as hard, dense and the smallest indivisible particle of matter, meaning it could not be broken into smaller parts. So this was the first idea. So this idea helped scientists understand that atoms are the basic building blocks of everything around us. Moving on to the next postulate, an atom is indestructible, meaning it cannot be either created or destroyed during a chemical reaction. Instead, atoms only rearrange to form new substances. But before and after the reaction, the total number of atoms remain the same, right? Third one, an atom is very small part of the matter that combines with other part to form new things. It is the smallest piece that can participate in chemical changes. Atoms are like the building blocks of all materials in chemical reactions. they cannot be divided into similar pieces, smaller pieces. It is the basic unit of the elements. Next, atom combines with each other to form compound or molecule in simple whole number ratio. Next, we have atoms of the same element are identical in both their masses and chemical properties. This means that every atom of any particular element has the same weight and behaves similarly in any chemical reaction. Now, next we have in chemical reaction, the atoms of reactants are rearranged to form new products. Atoms themselves remain unchanged, only their connections change, resulting in the formation of new substances with different properties. So, any doubt in these 5 postulates? Okay, so what is reaction yield? So, basically, suppose you are doing a reaction. So, just note it down, it will help you. Suppose you are doing a reaction where you have taken hydrogen and chlorine. Okay, so hydrogen gas is H2 and your chlorine gas is Cl2. Got it? Now, if you do this reaction, what will be the product? It will be 2HCl. What it will be? It will be 2 moles of HCl. Obviously, this will be your outcome. Now, suppose the reaction starts and after this reaction H2 plus Cl2, rather than getting 2 moles of HCl, you are getting only 1 mole of HCl due to the reaction condition. So basically I am telling that any reaction that you take, it is not necessary that due to the availability of the reactant, all of the reactants will be converted into product. It will attain a state where the equilibrium will be attained and the reaction will not proceed further. So what I said that you were expecting 2 moles of HCl. But what did you get? You get only 1 mole of HCl. Means half the reaction has proceeded and it stopped in the halfway. Now, if you want to calculate the reaction yield, what you will do? Your actual yield that you got was 1 mole and the expected yield was 2 mole of HCl. Therefore, your reaction yield will be 1 by 2 into 100. I hope you got my point, right? So, in this way, you can calculate the reaction yield for any given reaction. Moving on further. So, if you have a doubt, you can ask about this Dalton's law. Next, we have the fundamental laws of chemical combinations. So, these are the basic laws that explains how elements combine to form compounds. First of all, the first law is laws of conservation of mass, which was given by Lavoisier in 1789. It states that when a chemical reaction occurs, the total mass of the reactants which are initially present is always equals to the total mass of the product which are formed after the reaction. This means that regardless of the changes in the reaction, atoms are neither created nor destroyed. Only their rearrangement occurs. This law explains to us that matter is conserved in every chemical reaction. The next one, the law of constant composition or the law of definite proportion, which was put forth by the Proust in 1799. Okay. Now, according to this, what does it mean? It means that any pure chemical compound always contain the same element in the fixed percentage by mass, regardless of how or where that compound was prepared. Next, we have law of multiple proportion, which was given by Dalton in 1803. It states that one element combine with another element to form more than one compound. When this happens, the masses of the second element that combines with a fixed mass of the first element are always in whole number ratio. Now, this is a difficult statement to grasp. Let us understand the same with the help of an example. So, we are taking the reaction of nitrogen and hydrogen. So, nitrogen and hydrogen can combine in two different ways. Means it can give two different products. What are those products? First one is ammonia, which is NH3. So, nitrogen and hydrogen can react to form ammonia. The second product which is possible is hydrazine, given as N2H4. Means N2 plus H2 can give you NH3 and N2 plus H2 can give you N2H4. Okay, we can balance this equation. That is another part. But basically here I am telling that you are getting different products by reacting two similar reactants. Okay. Now, here in this case, if we take a fixed amount of nitrogen, then the amount of hydrogen in these two reactions will be in a simple ratio of 3:2. Okay. What did I mean? So suppose you take this N2H4. Okay, you take this N2H4. Then here 2 moles of nitrogen are attached with 4 moles of hydrogen. Now, if you keep the number of moles of nitrogen as 1, then what will be the number of hydrogen? In that same proportion, it will be 2. So basically 1 mole of nitrogen will combine with 2 moles of hydrogen to form this hydrazine. Now, in the case of ammonia, that same 1 mole of nitrogen will react to form with 3 moles of hydrogen. Okay. So here the ratio of hydrogen is changing. It is changing from 2 to 3 if we move from hydrazine to ammonia. So you are keeping the mole of nitrogen same, that is 1, and you are changing the mole of hydrogen from 2 to 3. So their ratio is 2:3. So this is your law of multiple proportion. Moving on to the next law. The next we have the law of equivalent or reciprocal proportions, which was put forth by Richter in 1794. It states that when two different elements combine separately with a fixed amount of third element, then the ratio of their masses in which both combine with the third element will either be the same or a simple multiple of the ratio in which those two elements combine with each other. For example, carbon combines with hydrogen to form methane and combines with oxygen to form carbon dioxide, whereas hydrogen combines with the oxygen to form water, which is H2O. So the combining ratios of these elements follow this law, which shows that there is a consistent relationship between their combining weights. Right? So this is the fourth one. Yes? What is your doubt? You can just tell it. For a detailed lecture, you can just visit our website. So we have detailed lecture of the same. Moving on to the next one, the law of combining volumes. So which was given by Gay-Lussac in 1808. So this is very, very interesting. It states that when gases react with each other or are formed in a chemical reaction, they always combine in simple whole number ratios by volume, provided that the gases are measured at the same temperature and pressure. For example, if you take, so 2 volumes of hydrogen reacts with 1 volume of oxygen gas and results in 2 volumes of water vapor. So this law helps us understand the behavior of gases during reactions and also shows us that the volume of gases are related to each other in simple ratios. What is the meaning of this? So basically, suppose you want to form water, then you will take 2 volumes of hydrogen, or what you will take for the oxygen, 1 volume of oxygen. So what is the ratio between these two? It is 2:1. So they are simple whole number ratio. You can take one more example. Suppose you are taking the example of formation of ammonia. Then what reactant do you take there? You take N2 plus 3H2, right? What do you take? You take N2 plus 3H2. What will be the product? It will be 2NH3. Now here you have taken 1 volume of nitrogen, right? And 3 volumes of hydrogen. So here also their volume are in a simple ratio. What is the ratio? It is a whole number, which is 1:3. Right? So similarly, you can take more examples for formation of gases where initially the reactants, which are gases, they react in simple whole number ratio of their volume to form the new products. Moving on further, we have this Avogadro's law. Now this is also very, very important, and you can just think of it in a way. Suppose you are taking 2 boxes, right? You are taking 2 boxes. And what are you doing? You are taking 2 different gases in those two boxes. In one you are taking hydrogen, in other you are taking oxygen. Then what you can say, if you keep the temperature and pressure constant in both of them. So 3 things are kept constant. What? In those 2 boxes, you keep the volume constant, you keep temperature constant, you keep pressure constant in these two, right? Means if one is having 22.4 liter, the other will also have 22.4 liter. If one is having a temperature of 273 Kelvin, the other will also have a temperature of 273 Kelvin, and same can be said about pressure. But in those two boxes, the thing which is different is your gas. So if you take hydrogen, and in the second you take oxygen. So this is your thing. Now, if you do so, then what you will observe? You will observe that both of them have the same number of particles. So again, I am repeating it. So if two different gases are kept at same volume, same temperature, and same pressure, then both of them will contain equal number of molecules. Right? Is it clear? Any doubt in this? So this Avogadro's law is very, very important. We can take an example of the same. How? Suppose we are taking two gases, and those two gases are having a volume of 22.4 liter, right? And you are taking STP, means the standard temperature and pressure. Pressure is of course 1 atm as standard, and temperature is 273 Kelvin. Then what can you expect? What will be the number of moles in both of them? Anyone who can reply to this? Again, I am repeating the question. So there are two boxes. One box contains hydrogen, the other box contains oxygen. Both have a volume of 22.4 liter and pressure 1 atm and temperature 273 Kelvin. Then what is the number of moles in case of hydrogen, and what is the number of moles in case of oxygen? So what will be your answer? So we have talked about this. So it's very simple to do. Your volume is kept at 22.4 liter. You know this value, right? We have talked about this 22.4 liter volume. Anyone? So we can calculate the number of moles if you know the volume and all. So yes, that will be same. The number of moles will be same. But what will be that value of moles? Yes, the number of moles will be same. If I keep it at 22.4 liter and if I keep it at STP, the volume will be same. Yes, that is good. Good for that answer. But what is the actual number of moles? What is the value of number of moles? So we have seen this in the previous lecture where we saw how to calculate the number of moles using the volume. There we used a value. Anyone? So if your volume is 22.4 liter and if your pressure and temperature are at standard condition, what will be the number of moles? Yes, it will be 1, not 2. 1 in both of them, right? The number of moles will be 1 in both of them. In case of hydrogen and oxygen, both will have the same value, and that is 1 mole, right? Okay. Now moving on to next. So remember, this is very, very important to remember, okay? Next we have atomic mass and its linked to specific heat. So this is something which will be helpful in your calculations and all. Now starting with the first one, which is atomic mass. How do we define it? So it is defined as the number which indicates how many times the mass of an atom of the element is heavier to 1/12 of the mass of one atom of carbon-12. So let me make it simple for you. Suppose you are knowing that what is the mass of one atom of hydrogen, and that you should know in grams. What did I say? Mass of hydrogen in grams, right? Now if you want to calculate the atomic mass of that hydrogen, how do you calculate it? So for that you have to use 1/12 of the mass of a carbon-12 atom. So just write it down. Suppose that the mass of your hydrogen is 1.67 into 10 to the power minus 24. So this is your mass of one hydrogen atom in grams. Then in the denominator, what do you write? You write the mass of one carbon atom. And its mass in grams is 1.99 into 10 to the power minus 23. So in the upper part, you will write 1.67 into 10 to the power minus 24, which is the mass of hydrogen atom in grams. In the lower part, you will write 1.99 into 10 to the power minus 23, which is the mass of carbon atoms in grams. Then it is written that you have to take 1/12 of that carbon 12 mass. So basically, you will divide 1.99 into 10 to the power minus 23 by 12. So this is your relative mass. So in a way, you are taking a relative mass, and to what relation? To 1/12 of the mass of a carbon 12 atom. When you do this calculation, you will find it surprisingly that the mass comes out to be 1.008 AMU, which is the actual mass of your hydrogen. So this is the overall idea of atomic mass. So you are trying to calculate your mass of atom, but in a different unit. Rather than using gram, you are using what? You are using unified mass here. And what is the conversion factor? The conversion factor is 1/12 of 1.99 into 10 to the power minus 23. So if you have mass of any atom in grams, you just divide that given mass of your atom by 1.99 into 10 to the power minus 23 by 12. And that will give you your what? Mass of hydrogen in AMU. Right? So again, I am repeating it. So atomic mass is nothing. It is simply the mass of one atom. But here, the unit which you are using is not gram. It is AMU. So you know that generally we measure the mass of your any object. If you take, you measure it in terms of kg, you measure in terms of grams. But in case of your atom, your mass is very, very small. So you can't use this gram, kilogram and all. So there you use AMU. And what is the conversion factor? It's very simple. You know the mass of a given atom, right? You divide the mass of that given atom by 1.99 into 10 to the power minus 23 by 12. If you divide this, you will get your atomic mass of hydrogen. So this is the definition. This is the meaning of your definition, or the soul of your definition. Next. Now the question arises, what is gram atomic mass? Now this gram atomic mass is simply your atomic mass, but it has a different unit. So you have three different things here. Remember these three different things. So first one is atomic mass, which is represented in terms of U. For hydrogen it is 1, for chlorine it is 35.5 U, then for oxygen it is 16 U. Then if I talk about the gram atomic mass, you simply replace your U with G. Okay. So if you try to calculate the gram atomic mass of hydrogen element, it will be 1.008 grams. As simple as that. Means the numerical value is same. What you are doing? You are just replacing the unit. So gram atomic mass and atomic mass have the same unit, only the difference is there in the unit. Then we have this molar mass, which is the third terminology. There also the value is same. What is different there? Again, the unit. There we write it as gram per mole. So remember these three things. Atomic mass is expressed in terms of U or AMU, unified mass or atomic mass unit. Then gram atomic mass is expressed in terms of grams. Second thing. And third thing is your what? Third thing is your molar mass, which is represented in terms of gram per mole. Got it? I think you are getting the point. So it's very, very important to remember these three things. They are just three different definitions from three different perspectives. In the first case, atomic mass, you are calculating the mass of one atom in terms of AMU. Yes, the numerical value is same and the unit is different, and therefore the perspective is also different. Okay, so all of them have three different meanings. Atomic mass is for the mass of one atom, whereas your molar mass is for the mass of 1 mole of that substance. Actually, their value remains same and the unit is different, right? So we have talked about this a lot in the previous class also. Now, here is a simple important connection between the average atomic mass and specific heat. So maybe you will not use this, but it is a handy tool while you are doing the questions of thermodynamics. Now this is applied to solid element. First of all, remember this, except your beryllium, boron, carbon and silicon. What did I say? Again, I am repeating it. This relation is applicable to solid elements only. Exceptions are beryllium, boron, carbon and silicon. So suppose you know the specific heat of any given element, right? And then you are asked to calculate the average atomic mass. How you will calculate it? It's very simple. 6.4 by your specific heat. Now take the other way around. Suppose you know the specific heat and you want to know the average atomic mass or the atomic mass. How do you calculate it? It will be simply 6.4 by average atomic mass. So you can skip a very tedious calculation in your thermochemistry. Without doing calculation, you can easily get your answer as long as you know the specific heat if it is given in the question. I hope you are getting this relation. So we'll talk about the specific heat. If you don't know, don't worry, we'll talk about the specific heat in the upcoming classes of thermodynamics. Next. So we have done this. Now last is exact atomic mass. So exact atomic mass is equals to equivalent mass into valency. So for this thing, we will move on to equivalent weight, where we will discuss this thing in detail. Now, before moving on to equivalent weight, let me tell you about average atomic mass. Now, to understand this, you must know one thing very important, that is isotope. So isotopes are the species which have the same atomic number but different atomic mass. Now, why do I need to encounter this? Suppose you are taking a sample of hydrogen, right? You know that the atomic mass of hydrogen is 1.008 U. So that is for sure. But when you are taking a sample of hydrogen, natural hydrogen, then it will contain, what it will contain? It will contain 3 isotopes of hydrogen. First is protium, second is deuterium, and third is tritium. What did I say? Again, I am repeating it. If you are taking a sample of hydrogen, then it is for sure that your sample of hydrogen will contain 3 different types of isotopes. What are isotopes? Those species which have the same atomic number but different atomic mass. Suppose you are taking hydrogen, then it will contain protium, deuterium and tritium. What is the difference between these 3? These 3 have the atomic number of 1, but their atomic mass is 1, 2 and 3 respectively. But whenever we are doing any calculation, we need to take one value of the atomic mass. But in any sample that you take, we will have atoms that will have value of atomic mass greater than 1. Now, how do you encounter this? How do you take the actual value or the right value of hydrogen? So we will now talk about that thing. Suppose, so questions are asked from here. Many times I have seen question from this relative abundance. So as most elements have isotopes, their actual atomic mass is the average of the atomic mass of all isotopes. So let me just make it clear with the help of this formula. How can we calculate the average atomic mass? MAV in the subscript is equals to M1R1, where M1 is the atomic mass of one of the isotope, right? And R1 is the relative abundance. So this thing will be given in your question. Maybe this thing can be given in terms of percentage. In that case, you will divide your percentage by 100 to get your relative abundance in terms of fraction. Okay, remember this is very, very important. Plus M2 into R2, where M2 is the atomic weight of the second isotope and R2 is the relative abundance, okay, fractional relative abundance of that second isotope, plus M3 into R3, where M3 is the atomic weight of the third isotope multiplied by the relative abundance of that third isotope. So here we are considering the hydrogen, and hydrogen has 3 isotopes. So you can take these 3 things. Okay, there may be a possibility that the given element has more than 3 isotopes. Then you can further extend this formula as M4R4 or M5R5. So that depends upon the question, divided by the relative abundance, the fractional relative abundance, sum R1 plus R2 plus R3. Okay, so this will give you your average atomic mass. Now let me tell you an interesting thing. Whenever you are taking the atomic mass of any given element, then in most of the cases, it is not the atomic mass, but your average atomic mass. Why do we take the average atomic mass? So that you can take your consideration from each and every isotope, because whenever you take a sample of any element, it is most probable that your sample would contain every isotope of that element in a certain amount. Now, to represent or to resemble that percentage, we take the average. Okay, so how do we take, how can you understand it? Suppose in your class, multiple students are there, right? Each and there is an examination of your boards, and you got different numbers. Now, if someone asks that what is the performance, how was the performance of your class, then what you will do? Will you take the number of the one who is the topper, or will you take the number of the one who is at the middle one? So in that case, to represent the proportion from all students, what you will do is you will take the average, right? So similar to that, a given sample of any element can contain multiple isotopes, and to represent them equally in terms of their abundance, we take their average atomic mass rather than their actual atomic mass. And every atomic mass that you see or that you use is not the actual but the average one. Suppose if you take the case of chlorine, chlorine has also two isotopes, one is having 37, one is having 35 point something. Then you take the average in terms of the relative abundance, and then you get this 35.5 value which you use in your calculation. So every atomic mass that you use in your calculation is actually the average atomic mass, which is simply the outcome of the isotope that you are considering, right? Moving on further, next we have, so basically what we do in our normal calculation, rather than using this whole average atomic mass, we use the atomic mass term, but in actual you are taking the average atomic mass. So that should be in your mind. Now next is the molecular mass. What is molecular mass? So this is the sum of the weights of all atoms in terms of AMU that are present in a given molecule. Okay. Now, how do we calculate it? It's very simple. Suppose there are different number of atoms and of different types. You simply multiply the atomic weight of that given atom with their respective number and add all of them to get the molecular mass. So let me just give you an example to make you understand in a simpler term. Suppose you are taking the water and you have to calculate the molecular mass of that water. How do we calculate it? Very simple. You know that hydrogen has a count of 2 and atomic weight of 1. So you multiply 2 with 1. So that contribution comes from your hydrogen. Now what about oxygen? So the count of oxygen is 1 and its mass is 16. So 16 plus 2 will give you 18, and that is your molecular mass for your water. Easy to go, simple to understand. Now this 16 that you are getting, your molecular mass, it will have a unit U. Similar to the atomic mass, we have this molecular weight. Okay, so in case of atoms we have the atomic weight, in case of molecule we have the molecular weight. As simple as that, their unit is same. But suppose if you take molar mass of that compound, and again that U will be replaced by gram per mole, and if you take the gram molecular weight, then in that case your U will be replaced by gram. Yes, in most of the cases I see that the molecular weight of the elements are given in your question. If it is a typical one, right? So suppose it is coming from D block elements or F block element, you will see in most of the cases in your previous JEE exams also or NEET exams also that their weight is given. So you don't have to worry about that. Yes, there may be a chance for smaller or lighter element, their atomic mass would not be given. So at least you need to remember for till nitrogen section, right? So there will be nitrogen, oxygen, so that one, right? After that, I hope you will get it. Moving on to the next one, which is formula mass. Now, why this formula mass was introduced? To understand this thing, you must know what are ionic compound. So suppose we take the example of NaCl. Now, can we calculate molecular mass for NaCl? Is it relative? No. Why it is not relative? Because NaCl is ionic. It is an ionic compound and it has no existence as a molecule. So there is no point of naming it as molecular mass. Rather than that, for the case of NaCl, we take the formula mass. Did you get it? So again, here the value, the way of calculation is same. Suppose you are taking NaCl. So what is the case of NaCl? There is one sodium molecule and there is one chlorine molecule. So how you will calculate the formula mass? Similar to the way you are calculating the molecular mass, which is the atomic weight of sodium plus the atomic weight of chlorine, which is 23 plus 35.5 comes out to be 58.5 AMU or 58.5 U. But here you will not say that this given value is the molecular mass of NaCl, because NaCl cannot exist as molecule, it exists as ions. So for that case, you will tell it as formula mass of NaCl. So you don't need to get confused. It is just the way of telling, or just the better way to tell the mass of one NaCl molecule. The idea is same. Here again the unit is taken as AMU or U, similar to the case of molecular mass. Okay, one more important thing. This AMU and U are used frequently. Now AMU is something which was used in the past times for representing the molecular weight, but in the recent times this AMU is being replaced by U. So AMU means atomic mass unit and U is unified mass. So basically it is a replacement. So U is replacing the AMU. Okay, so you don't need to confuse. So in the previous books, if you see older books, you will see AMU which is used as the units, but later on the IUPAC system upgraded this, and now rather than using AMU, we use the U. Now we will move on to one of the important topics that we were confused yesterday about equivalent weight calculation. So in the normality part, we need the equivalent weight and then we divide that equivalent weight by volume to get the normality. But we don't know how to calculate that equivalent weight. Today we will discuss that thing also. And one more important thing related to that is your N factor determination. So I will suggest you that you must attend the DPPs. So there are DPPs given in on our websites, and from time to time we will also introduce you with the mock tests. So that will be enough, and apart from that, practice questions that are as much as possible for you. Take for example PYQs and all and practice those. Okay, so that would be enough for you. Now moving on to the next one. So what is equivalent weight? So weight of an element or of a compound which would combine or displace one part of hydrogen or 8 parts of oxygen or 35 parts of chlorine. Now this is something which is confusing. We will move directly on to the formula to get the proper idea behind this. How do we calculate the equivalent weight? Very simple. Suppose you are given an element, right? And you know that what compound it is forming. Then from that you can calculate the equivalent weight. How do we calculate it? Atomic weight or molecular weight divided by N factor. Now you ask me, what is this N factor? How do we calculate it? Now this N factor has different perspective depending upon its application, where it is going to used. For example, we will start with the acid base reaction. Okay, so you are doing so this equivalent weight is mainly used for reactions and all, you know it very well. Now you want to calculate the equivalent weight for an acid. Okay, so two species are there, one acid and one base. Now you want to know what is the equivalent weight of that acid. How do we calculate it? So it depends upon the number of H plus, the number of ionizable H plus, or it is also known as basicity, right? So If you want to take an example, we can take HCl. So for HCl, your basicity is 1 or the number of ionizable H plus is 1. If I tell you what is the equivalent weight, how do you calculate the equivalent weight? So simply take the atomic weight of HCl and divide it by 1. That will give you your equivalent weight of hydrochloric acid for a acid-base reaction. Okay. Yes, molecular mass and molecular weight are the same terms, exactly the same terms. They will have the same formula, same unit and all. So don't have to worry about that. Now coming back to this. So for acid-base reaction, the N factor of acid is the number of H plus that can be given by a particular acid. Right? So for HCl, here the N factor will be 1. And if you want to calculate the equivalent weight, you will take the atomic weight of hydrochloric acid, which is 35.5 plus 1, means chlorine's atomic weight plus hydrogen's atomic weight. So 36.5 divided by 1. So that will give you your equivalent weight of the HCl. Okay. Next, we can similarly calculate it for base, but there you have to look for number of ionizable OH minus. For example, if you take NaOH, what will be the N factor? It will be equals to 1, right? Now, what will be the equivalent weight? 23 plus 16 plus 1 divided by 1. Okay, so that will be your equivalent weight for NaOH. Now, let me give you a question for you. So, if I ask you, what is the equivalent weight of your CaOH whole twice? Okay, you know what is CaOH whole twice? It is calcium hydroxide. So, what is the equivalent weight of calcium hydroxide? How you calculate it? So, first of all, you need to know what is the N factor. So, what will be the N factor for calcium hydroxide? What is the value of the N factor? Anyone? What is the value of N factor for calcium hydroxide? So since it is a base, what do you need to know? You need to know the number of OH minus it can donate. So from that perspective, what is the N factor? Yes, it will be 2. The N factor of calcium hydroxide will be 2. Now, what is the the molecular weight of calcium hydroxide? How do you calculate it? What is the molecular weight of calcium hydroxide? So you take the atomic weight of oxygen, you take the atomic weight of hydrogen, add both of them, right? Multiply it by 2 and add it with calcium. Then you will get what? You will get your molecular weight of your calcium hydroxide. Is it clear to you? Now, once you got this molecular weight of calcium hydroxide, which will come out to be 74.009, you will divide it by 2 to get the equivalent weight of your calcium hydroxide. So in this way, you can calculate it for bases. Now you know that how do you calculate the equivalent weight of your acid and base in any acid-base reaction. Now, question arises, how do we apply it? Where do we use it? When you will come across your redox reaction chapter, there we have equivalence concept and there we widely use it. Okay. So for the time being, you should remember. Moving on further. Yes, very good. Moving on further. Next we have N factor for salt. So for salts also we have this N factor. So it is very easy to calculate. It is total positive or negative charges of ions. Now, suppose we are taking the case of Na2CO3. So what is the charge on the cation, or what is the charge due to cation? It is 2. What is the charge due to carbonate? It is again 2. For it, you will see this concept in redox reaction. Okay. Now, here the charge due to cation is 2 and the charge due to carbonate is 2. Therefore, in this case, the salt will have an N factor of 2. Clear? I hope you are getting the point. So for any acid-base reaction, you can easily calculate the equivalent weight using the number of H plus that is being donated or number of OH minus that is being donated. Or you can calculate it for salt also by calculating the charge which is coming from cation or from your anion. Of course, they both will be equal so that overall the compound can be neutral. No. So basically we are calculating the overall charge that is coming due to cation. Now one sodium is having +1 charge, and since there are 2 sodium plus atoms, so overall charge due to cation will be 2. Right? Yes, you can calculate it anyway. Okay. So we can now move further. So this was all for the N factor calculation in case of acid base reaction. Yes, it is 2. N factor for Na2CO3 is 2. Now what about the case where we have redox reactions? Of course, we will have a redox reaction. Now N factor for that case, if it is an ion, then it is simply equals to its charge. For example, if we are calculating the equivalent weight of chloride ion, Cl minus ion, then what is the N factor? In case of that ion, we will simply take the charge, the absolute value of charge, not the negative sign, but the absolute value of charge. That will be your N factor for chloride ion. Now, what is the atomic weight of chlorine? It is 35.5. Therefore, the equivalent weight of chloride ion is 35.5 divided by 1, which is 35.5 again. I hope you are getting this one. It's very simple to understand. Now, this thing is not for your any particular reaction. It is applicable to all. So, the previous one that you saw was for acid-base reaction. And this ion thing is applicable to all reactions. Now, why we are calculating this equivalent weight? What is the reason behind it? So, basically, it is used in the reaction. Right? So, we have talked about this in the previous class also. Remember, I said that if you have 1 mole of H2SO4, what do you have? You have 1 mole of H2SO4 and you have 1 mole of NaOH. So, will there be complete neutralization? All of the acid will be neutralized by the present base? The answer would be no. It would not be neutralized because 1 mole of H2SO4 will give you 2 moles of H plus ion. That means double the quantity of base. Right? Now to neutralize this completely, you will need 2 moles of NaOH. Now in this case, you have to make the equivalents equal. Means the equivalent equal on both sides. For that reason, we are dividing it by 2. Right? You got my point? Now suppose if I ask you, what is the equivalent weight of your HCl that is required to completely neutralize 1 mole of NaOH? You will say that, okay, it's very simple. I will simply take the mass of 1 mole of NaOH. It is equals to how much? It is equals to 23.5 plus 63. So 23 plus 16 plus 1 divided by 1. Okay. Now you will take half mole of HCl. Okay. So this is the basic concept behind your equivalent weight. Means how much thing is required to neutralize the other counterpart. Moving on to the next application of this N factor, which is your redox reaction. So any doubt till this point? Do you are getting the point of equivalent weight? So this in redox reaction, before moving on to that, you must know how do you calculate the oxidation state. So it's very simple to calculate, right? Now keeping that thing in your mind, how do we calculate the N factor? So N factor, if you are calculating it for the reducing agent, means the one which is getting oxidized. So the one which is getting oxidized will reduce the other. So it will be a reducing agent. So N factor for any reducing agent is the number of elements, number of electrons lost by the molecule. And for the oxidizing agent, it is the number of electrons gained by the molecule. Now for that case, for the acid-base reaction, you will use that equivalent concept in case of equilibrium also, ionic equilibrium. So just keep this concept handy and practice it as much as possible. Then you will use that same thing in the ionic equilibrium. Now coming back to this, what is the N factor for reducing agent? The substance which is getting oxidized. So it is simply the number of electrons that it will lose. And for the oxidizing agent, it is the number of electron which is gained by the molecule. example, if we take the case of ferrous sulfate FeSO4. Now this FeSO4 can act as reducing agent. How? So for reducing agent, it will go from Fe2 plus to Fe3 plus. So here it is getting oxidized. Now it is releasing electron and that will be accepted by another species. So that substance will get reduced. So it is acting as a reducing agent. Now the question arises, what is the N factor? I would say that since one electron is released, therefore the N factor is 1. As simple as that. If I further tell you what is the equivalent weight, then you will divide this N factor, put it in the denominator, put the molecular weight of your FeSO4 in up part, or you can take it for Fe also. Okay, you can take the atomic weight of Fe also, because in case of ionic reactions, we will see that we don't get the whole molecule, rather than we get the ions in the given reaction. Okay, that would be a later part of the redox reaction. We will move there, we will see that also. But here you must know this thing, that N factor for Fe2 plus is 1 if it is a reducing agent, because it is giving 1 electron. Now, suppose it acts as a reducing agent, oxidizing agent. Then what will be your answer? What is the next oxidation state that it can go? Remember, if it is acting as an oxidizing agent, it will accept electron. Now, can it go to Fe plus? Is it possible for your iron? Or will it directly go to Fe? Just tell me. Again I am repeating it. If your Fe2 plus is acting as an oxidizing agent, whether it will go to Fe plus or it will go to iron directly. Anyone who can answer this? It's very simple. You know what are the common oxidation states of iron? So we have 3 plus for sure, because there it is given in the above part. We have 2 plus. But is Fe plus possible? Have you seen Fe plus in any compound? I hope you have not seen this. It will of course go to Fe. Okay. Remember, not Fe plus. It will go to Fe. So if it will go to Fe, then what will be the N factor? In case it is acting as an oxidizing agent, it will be 2. Very good. Where it will go? It will go to Fe, and there for this, since it is acting as an oxidizing agent, it will have N factor of 2. Got it? Now, further, if you want to calculate the equivalent mass, you know this formula. You will simply take the molecular mass of the oxidizing or reducing agent. Suppose if I take it for FeSO4, you will take it for Fe2 plus, right? You will take the molecular mass of Fe2 plus, or I will not say molecular mass, the atomic mass of Fe2 plus, divided by the N factor, right? So in this way, you can calculate the equivalent mass. Now we have covered the theory part. Now we will move on to the question part. So just wait for a while. I will switch on to the question. Okay. So we will see PYQs. Yes. So next we will have the physics class. Don't worry. Sorry, math class. And after that, we will have the next math class. But before that, we have some questions here. Okay. So there will be total of 10 questions. Let's see how much we can solve. So this is your first question, right? Question asks us the total number of electrons present in 18 milliliter of water. Now here the density of water is 1 gram per ml. You have to calculate what is the total number of electrons. Options are A 6.023 into 10 to the power 23. Then we have 6.023 into 10 to the power 24. Then we have 6.02 into 10 to the power 25. Let's see how we can solve it. So if you know, you can just solve it by yourself. Meanwhile, I will show you the solution. The correct answer will be 6.02 into 10 to the power 24. Let's see how we can solve it. Again, I am repeating the question. So you have 18 milliliter of water. What do you have? You have 18 milliliter of water. The density of the water is given and you have to calculate the number of electrons that are present in 18 milliliter of water. The correct answer will be C. Okay. So let's move on to the solution. Just move with me step by step. It's very simple to understand. You will get the notes of the same on our website. It is given along with the video lecture. So just log into that. And for login detail, you can just visit our first session, the day 0 session. You will get the notes from there. Now, moving on to the solution. First of all, we need to calculate that how much amount of water is present in grams in 80 ml of water. Okay. Now we know that the density is given. We know that density is equals to mass per unit volume. To calculate the mass, we have to multiply the volume with density. If you do so, 18 ml multiplied by 1 gram per ml. What it will give you? It will give you 18 gram H2O. Now, in 18 gram H2O, we have 1 mole. Now, this is something which is written directly. Do you have any confusion in this part? How are we getting this? Again, I am repeating it. We know that the density formula is mass per unit volume. If you want to calculate the mass from density and volume, you will simply multiply density and volume to get the mass of water, which is present in 18 milliliter of water. So, it will be 18 gram. Is it clear to all of you? So, this is the first part. Now, the second part, how much mole is present in 18 gram of water? How do we calculate it? So, we know the formula of calculation of mole. What is that formula? Given mass by molar mass. So, the given mass which is present in 18 milliliter is 18 gram. And the molar mass is also 18. So, given mass is 18, molar mass is 18. Therefore, the number of moles is 1. Is it clear? So, this is the first equation that I have written. So, 18 milliliter will contain 1 mole. Now, what is the second thing that we know? That 1 mole of anything that you take, rather, irrespective of the entity that you are considering, you will always get Avogadro number of that same entity. Here, since that entity is water molecule, therefore, in 1 mole of that water molecule, you will get 6.023 into 10 to the power 23 molecules of water. Or we can tell it directly that 18 milliliter of water contains 6.023 into 10 to the power 23 molecules of water. If you are facing difficulty, just take out a notebook and pen with you and do the calculations along with me so that you can get a clear picture of what I am doing. Got it? I hope you are getting it. Yes. Now, moving on further. If this is clear, then what is the second thing that you know? What is the number of electrons in 1 molecule of water? How do we calculate it? Now, for that, you must know the atomic number of this hydrogen and oxygen, which are the components of water, right? So, for hydrogen, the atomic number is 1. So, the number of electron will be 1. For oxygen, the atomic number is how much? It is 8. So, the number of electron will be 8. Now, since 2 hydrogens are there, so 2 electrons are coming from hydrogen and 8 is coming from oxygen. Therefore, the total number of electrons which is coming from 1 molecule of water is 10 electrons. Is it clear to all of you? Any doubt in this? How do we know that 10 electrons are present in 1 molecule of water? It's very simple. 8 is coming from oxygen and 2 are coming from 2 atoms of hydrogen. Since one molecule contains 10 electrons, therefore 16.023 into 10 to the power 23 will contain how much? Very simple, multiply both of them. So It is quite simple. You can take a daily life example. So I see most of the students face difficulty in this simple unitary method. So just be with me. It's very simple to understand. Suppose you have a chocolate, right? And that chocolate costs you 2 rupees. Suppose you need to buy 10 chocolates of that same kind. So how much money do you need? You will need 10 into 2, means 2 is for 1. So therefore for 10 you will need 20 chocolates. So 20 rupees. So from that same idea, we have this unitary method. Your one molecule has 10 electron. So your 6.023 into 10 to the power 23 molecule will have 10 into 6.023 into 10 to the power 23 electrons. And that will give you a total of 6.023 into 10 to the power 24 electrons. Means 18 milliliter of water contains 6.023 into 10 to the power 24 electron. So if I just summarize this whole calculation, first we calculated the mass from density and volume that we have. Then from the mass, we divided it with the molar mass to get the number of moles. And we know that in 1 mole, we have 6.02 into 10 to the power 23. Now, in 1 molecule of water, we have 10 electrons. So in 6.023 into 10 to the power 23, we have 10 into 6.023 into 10 to the power 23 electrons. That is 10 and 10 into 10 to the power 23. If they are multiplied, their power is added, 23 plus 1, 24. And this is your final answer. Any confusion? So is it clear to all of you? It's a tricky question. So I have seen most of you are making mistake and writing an answer as 6.023 into 10 to the power 23 rather than 24. Because you were considering 1 electron. But 1 molecule has 10 electrons. Any doubt in this? So if you have a doubt, you can ask, or we can move further. So it's a very simple one. It will give you a clear concept of your mole concept. Okay. Yes. So we'll move on to the next question. What is the next question? Again, we have a question from mole concept. So the more question you solve, easier this mole concept becomes. So this is the basic fundamental of this mole concept. Now the question says that the weight of 1 into 10 to the power 22 molecules of CuSO4.5H2O is. Okay. Now, okay, electron part. So basically, you can think of it. So we know, did you get the point that we are having 6.022 into 10 to the power 23 molecules of water in 18 milliliter? If that thing is known to you, and you also know that 1 molecule of water contains 10 electrons. So therefore, for Na number of electrons, you will multiply 10 with your Na. Okay. It's very simple. Just think it analytically, you will get it. Now, next one. The weight of 1 into 10 to the power 22 molecules of CuSO4.5H2O is to be calculated. 4 options are given here. 41.59 grams, 415.9 grams and 4.159 grams. None of this, the fourth option. Now, question arises, how do you calculate it? In most of these questions, your first idea should be to calculate the number of moles that is there in 1 into 10 to the power 22 molecules of your pentahydrated copper sulfate. So I am telling this CuSO4.5H2O as pentahydrated copper sulfate. So how do you calculate the number of moles using the number of particles? I have given you a formula. So we have 3 formulas: given mass by molar mass, given volume by 22.4, and the fourth one is given number of particle by Avogadro number. So the third formula is applicable, right? Where you divide the number of particle by Avogadro number. Okay, so from that we can calculate the number of moles. Now, for those who have calculated this, the correct answer is 4.159 gram. So if you are not getting that answer, no worries. It's a simple one. You will get it. Maybe you are doing a mistake in your calculation. If you're getting the thing, if you're getting the concept, it is well enough. Now, moving on to the solution. So, first of all, what I will do, I will calculate the molecular weight of your CuSO4.5H2O. Now, why I am saying it that this molecular weight is the mass of 6.023 into 10 to the power 23 molecules, because it is known to you that in a given molar mass, the number of molecules would be this. Is this first statement clear to you? That your molar mass of your CuSO4.5H2O will contain 6.023 into 10 to the power 23 molecule. So we have talked about this a lot. Now, if you do this calculation, you will know that Na number of molecules of CuSO4 will contain 249.5 grams of that pentahydrated copper sulfate. Is this thing getting in your head? This first statement? What it is saying? It is saying that if you calculate the molar mass of your pentahydrated copper sulfate, you will get the mass of 6.023 into 10 to the power 23 molecules of that. Okay, so that is clear to you. I think you're getting this point, right? So moving on further. Next, what we have? Next, we have the number of particles. So we have seen this thing to calculate the number of moles from the number of particles. What do? We simply divide this 10 to the power 22 by Na. So I have done the same thing. And this would be what? This would be the number of moles. Now, the number of moles is multiplied by 249.5 to give you the overall mass of this 1 into 10 to the power 22 molecules. So I hope you are getting this reaction right, this equation right. So what did I say? So first you calculate the number of moles. You know that 1 mole of this CuSO4.5H2O has a mass of 249.5 grams. Okay, first thing. Second thing, if you know that the number of moles is calculated by using the formula given particle by number of particle in 1 mole, that is 6.023 into 10 to the power 23, then you can get the number of moles from here. 1 mole has a mass of 249.5, therefore 10 to the power 23 by 6.023 into 10 to the power 23 will have a multiplication factor of 249.5 to calculate the actual mass. Is it clear to all of you? Is there a doubt in this? So first you will calculate the mass of 1 mole, you will calculate the number of mole, and then you will multiply the number of moles with the mass of 1 mole to calculate the total mass of that substance. Okay? Any doubt in this? Any issues in this? So we can move to the next question. Okay. So moving on to the next one. Next, what we have? We have this next question. The number of moles. So what is the doubt? Okay. So the question is saying that you have a number of particle of CuSO4.5H2O. So first you note it down so it can help you. Okay. We have directly used this unitary method. Okay. Now this thing is clear too. You have to calculate the mass of 10 to the power 22 molecules of CuSO4.5H2O. Now to do this, first we have calculated the number of moles. To calculate the number of moles, we simply divide the given number of particles by the Na. So it will give you your number of moles which is present in 10 to the power 22 molecules of CuSO4.5H2O. Okay, so this is the first part. Next thing, you know that 1 mole of CuSO4.5H2O has a mass of 249.5. We have seen this in the previous part, right? Okay. So what is the doubt? You can just post it directly. Now you know the mass of 1 mole and you know the number of mole. Then how do you calculate the mass of that number of moles? You simply multiply the number of moles with that mass of 1 mole. Okay. So similar to your chocolate case, if you know the cost of 1 chocolate and if you know the number of chocolate that you have to buy, then you can calculate the total spend here. Here you know the number of moles, you know the total number of moles, multiply both of them to calculate the mass of total moles. Is it clear to you? So first we have calculated the moles and multiplied it by the molar mass. Moving on to the next one. So here you have to calculate the number of moles of NH4 whole twice SO4, Fe2, SO4 whole thrice, dot 24H2O formed from a sample containing 0.0056 gram of Fe is, right? So you have to see that in this much moles of Fe, using this much moles of Fe, how much moles of this compound can be formed? 4 options are given. So this is a good one. This question is good. Okay, so let's see. We will move step by step. The correct answer for this would be 0.5 into 10 to the power minus 4 mole. Starting with the solution. So B is the correct answer. Very good. So first of all, what we will do? We have a mass of 0.056 gram for Fe. From there, we can calculate the number of moles of Fe. How do we calculate it? Given mass by molar mass. So the given mass is 0.0056 gram and the molar mass of Fe is 56 gram. So don't worry, you are not seeing the molar mass of Fe here, but in case of your JEE exam, you will get it for sure. Okay. So from this part, you can calculate the number of moles of Fe which is given mass by molar mass. Is it clear to you? So this is the first part and you get a number of moles of Fe as 10 to the power minus 4 mole. Moving further, now we have 2 moles of Fe present in 1 mole of this given compound. You can see it clearly from the question that 1 mole of this compound contains 2 moles of Fe. See, in the numerator we have 2 here. Now we have only 10 to the power minus 4 moles of Fe. So how much moles of compound can be made from it? So for that, you will again use the unitary method. So what can we say? For 1 mole of the compound, we need 2 moles of Fe. So from 1 mole of Fe, how much compound can be made? 1 by 2. And for 10 to the power minus 4 mole of Fe, how much can be made? 10 to the power minus 4 into 1 by 2. Now using this simple unitary method, you will get your number of moles of compound that can be formed from the given number of moles of Fe is 0.5 into 10 to the power minus 4 mole. Is it clear to you? You have a doubt? Do you have a doubt here? So basically, if you know the concept, the only thing that is missing in your preparation is that unitary method. So I'm telling it for the mole concept. I will suggest you, please go and practice as much as possible for the unitary method before you attempt this mole concept question, because in every question you would see that you are using a unitary method in a way or other. Okay? Got it? So rather than mugging up formulas, a large number of formulas, just remember the unitary method and that will help you to solve a large number of questions. So I will try to put up a lecture for this unitary method if you are not getting this. So we will see on to that in the upcoming lectures. Hope you will use that thing to solve this one. Okay. Apart from that, do you have a doubt in the mole concept or what I am using? So it's very simple to do, right? If I take this question, suppose. So here we are seeing that 2 moles of Fe is required for 1 mole of the compound. So 1 mole of Fe will be required for 1 by 2 mole of that compound. Now using for 10 to the power minus 4 mole of Fe, we will simply multiply it. Okay. So this was all for the chemistry class. Next, our maths faculty will see this. So thank you for joining the session. I hope you enjoyed it. So this were the PYQs. Don't worry. This all are the PYQs of JEE. You don't have to worry. These are all the PYQs. Right? So you are practicing the PYQs. Okay, just wait for a while. Our next faculty will join you in a minute.
Hello everyone. So welcome to day 2 of crash course. Today we will cover relation and function. This is disclaimer. Okay. So at first we do trend analysis for chapter relation and function for the last 5 year. The chapter weightage is 6%. So the exam point of view, relation function is very important chapter. If we see the last 5 year data, so in year 2024, total 2 questions come from the chapter relation function on the topic types of relation and types of function, and difficulty level is average. In year 2023, total 3 questions come from this chapter and the topic is domain and range of function, types of relation and composite function. In year 2022, 1 question come from the topic types of function, and in the year 2021, total 2 questions come from this chapter on the topic types of function and inverse of function. So this chapter is very important for exam point of view. Okay, so in today class, at first we will know about Cartesian product of set. So like if we have two set, then how we can product them. That is called Cartesian product. Then we will talk about relation. What is relation? What is composition of a relation? Then we will learn about what is function and what is the difference between relation and a function. Different types of function. Then method to check which function is one and which function is not a one function. Method to check many one function. Method to check onto function, and then method to check into function. So at first we will understand what is one function, many one function, onto function, into function. Then we understand how we can check whether it is a one function, many one function, onto function or into function. And at the last we will cover composition of a functions. Okay. The first topic is Cartesian product of sets. So let's suppose we have two sets A and B and both sets are non-empty sets. Okay. Then the Cartesian product, that is denoted as A cross B and is defined as set of all ordered pair. Okay. That means A comma B, where A come from set A and B come from set B. Here small a represent the element and capital A represent the set. So small a, that is the element, come from set A. So mathematically we can define Cartesian product as A cross B is equal to A comma B, this ordered pair, where A come from set A. The first element of ordered pair come from first set, that is A, and the second element of ordered pair, that is B, come from set B. So that's how we define Cartesian product of two sets A cross B. This is nothing but collection of ordered pair, where first element come from first set and second element come from second set. Now we define B cross A. We just reverse the order. Now B cross A is the ordered pair B comma A, where the first element come from first set and now the first set is B. So B come from set B and element A come from set A. That is your Cartesian product B cross A. And A cross A is defined as, that is Cartesian product of set A with itself is defined as the ordered pair A comma B, where A and B comes from set A. So that is your Cartesian product. One important thing is, if either A or B is an empty set, then A cross B is phi. In this case, the Cartesian product is an empty set because we cannot form any pairs. Because to form a pair in a Cartesian product, there must be an element in both set. Then we can form a pair. How we can calculate number of element in a Cartesian product of two sets. So let's suppose number of element in set A is P and number of element in set B is Q. Then number of element in set A cross B is NA into NB, that is PQ. So product PQ gives the number of element in the Cartesian product of set A and B. So we just need to multiply the cardinal number of A and B to get the cardinal number for Cartesian product. What is cardinal number for a set? The number of element present on that set. There is some formula related to Cartesian product. If we do Cartesian product of A with B union C, so the Cartesian product of set A with the union of set B and C is equal to A cross B union A cross C. So this is equal to the union of individual Cartesian product A cross B and A cross C. And the Cartesian product of A with B intersection C is equal to Cartesian product of individuals, that is A cross B intersection A cross C. So that's how we can calculate A cross B intersection C. Next one is A cross B minus C. So this is equal to A cross B minus A cross C, that is Cartesian product of set A with the difference between set B and C is equal to the difference between the individual Cartesian product A cross B and A cross C. Next is A cross B intersection C cross D is equal to A intersection C cross B intersection D. Okay. So what is the basic idea of Cartesian product? Cartesian product is set of ordered pair where first element come from set A and second element come from second set, that is set B, if we talk about A cross B. Okay, and to calculate the number of element in A cross B is just multiply the number of element in set A into number of element set B. Next, now we will talk about relation. So to define relation, we already learned about Cartesian product. So what will happen in relation? A relation is subset of Cartesian product. Okay. So let's suppose we have two non-empty set A and B. Then relation R is defined from set A to B. And it is a subset of Cartesian product A cross B. So A cross B is a collection of ordered pair. It is a set of ordered pair A comma B, where A come from set A and B come from set B. So the relation is just a subset of A cross B. That's how we denote R is a subset of A cross B. One important thing is A and B is a non-empty sets. Then we can define relation from A to B. So if this ordered pair A comma B belongs to R, that's how we read this notation, A comma B belongs to R. It means the element A from set A is related to element B from set B. That is, A is related to B. By which relation? By the relation R that is defined from set A to B and is subset of A cross B. Okay. And we write it as A capital R B, and we can read it as A is related to B. Okay. Now what is domain? So if you want to define a domain for a relation, then as relation is a subset of A cross B, so each element is a form of ordered pair. So in a ordered pair, if we collect all the first element in the ordered pair and make a set, then that set is called a domain of R. That is A colon A comma B belongs to R. So if we collect all the A's in all the ordered pair on the relation, then it is called domain of R. And what about range? So range of R, if we collect all the second element in the ordered pair of the relation, then that collection is a set, and the set is range of that relation R. Okay. So now if you want to count total number of relation from a particular set A to B, and if A and B is a finite set, so let's suppose number of element in set A is P and number of element in set B is Q, then total number of relation from set A to B is to the power PQ. So that is the formula to calculate total number of relation. Okay. So now types of relation. So let A be a non-empty set. Okay. And R be a relation on A. It means R is a subset. R is a relation, and relation is a subset of Cartesian product. So R is a relation subset of A cross A. So R is a relation from set A to itself. Okay. Then first type of relation is reflexive relation. And what is reflexive relation? A relation R, which is defined from set A to A, that is relation on A, is reflexive if and only if A comma A belongs to R for all A belongs to A. It means A is related to A for all A belongs to A. So if A is a set and we define a relation on it, that relation is R, then R is reflexive if and only if for each element A from that set A must relate to A itself. Then the relation is reflexive relation. Okay. Next types of one is symmetric. So what is symmetric? So the definition of symmetric is if A comma B belongs to R, then if B comma A is also belongs to R, for all AB belongs to A, then your relation R is a symmetric relation. Okay. So to understand that, if A is related to B, then if B is also related with A for all AB belongs to A, then the relation is symmetric relation. Next one is transitive. So a relation R is said to be transitive if A comma B belongs to R and B comma C belongs to R. Then if A comma C also belongs to R for all A, B, C belongs to A, then this relation is transitive relation. It means if A is related to B by relation R and B is related to C by relation R, and if A and C is also related with R for all A, B, C belongs to A, then this relation is called transitive. So to check a relation is reflexive, we have to check for each pair, for each A belongs to A belongs to R. To check symmetric, we have to check if AB belongs to R. Then if BA is also belongs to R, then it is symmetric. And to check transitive, we have to check if AB belongs to R and BC belongs to R. Is it AC is also belongs to R? If yes, then the relation is transitive. Okay. That is, if A related to B and B related to C, then if A related to C, then for all ABC belongs to A, then relation is transitive relation. Next type is identity relation. So what is identity relation? That is noted by capital IA. It is of the type A comma A, for A belongs to A. So if the relation is of this form, that is A comma A is related to itself, then such relation is called identity relation. Okay. We do some question based on this relation, then you completely understand what is reflexive, symmetric and transitive. Okay. Next type is equivalence relation. So R is said to be an equivalence relation if and only if it satisfies certain property. First one is it is reflexive. That means, what is the definition for reflexive? A comma A belongs to R for all A belongs to A. Okay. So this is your reflexive relation. It is symmetric if AB belongs to R. What is the definition for symmetric? If AB belongs to R, then if BA is also belongs to R, for all AB belongs to A, then this relation is symmetric relation. And for equivalence relation, the relation must be reflexive, must be symmetric, and also it must be a transitive. Okay. So what is the definition of transitive? If AB belongs to R and BC belongs to R, then AC should also belongs to R for all ABC belongs to A. Then if a relation is also a reflexive relation, a symmetric relation and transitive, then the relation is equivalence relation. Okay. So next topic is inverse relation. So let R be a relation which is defined from set A to set B. Then the inverse of R, that is noted by R inverse and is defined by R inverse is equal to B comma A, where AB belongs to R. So if A is related to B, then in the inverse of R, B is related to A. We just inverse it. Clearly, if AB belongs to R, it means A is related to B. Then on the inverse of R, B is related to A. And if in the inverse B is related to A, then on a relation A is related to B. That means if 1 is related to 2 on relation R, then 2 comma 1 is related with R inverse. Okay. There is some note. First one is the intersection of two equivalence relation on a set is an equivalence relation on the set. So if we define a two relation, let's suppose R and S, and both are equivalence relation, it means both are reflexive, symmetric and transitive. And if we take the intersection, we know how we intersect the two sets, then the intersection of both the equivalence relation is again a equivalence relation. Okay. Next one is the union of two equivalence relation on a set is not necessarily an equivalence relation on the set. So if we have two relation and that is our equivalence relation, and if we take the union of both relation, it may be equivalence and may not be. Okay. If R is an equivalence relation on a set A, then R inverse is also an equivalence relation A. So if R is an equivalence relation and we take the inverse of R, then that is also an equivalence relation. So next topic is composition of relation. So let's suppose we have two relation R and S, and the relation R is defined from set A to B, okay, and relation S is defined from set B to C respectively. Then we can define S composition R from A to C. So clearly observe here that set R is defined from A to B and set S is defined from B to C. Then a relation, that is composition S composition R, is defined from A to C, such that if AC belongs to S composition R, that means A is related to C with relation, that is composition relation S composition R, it implies there exists B belongs to B such that A comma B belongs to R and B comma C belongs to S. It means there exists B such that A is related to B with respect to relation R and R is defined from A to B. So A is from A and small b is from B, and B comma C belongs to S. It means B come from set B and C come from set C, and B is related to C with respect to relation S. Then A is related to C with function composition S on R. And if A is related to C, then A related to B with relation R and B related to C with relation S. And this relation, that is S composition R, is called the composition of R and S. And one important thing is R composition S need not be equal to S composition R. So composition of relation does not satisfy your commutative property. Okay. So composition of SOR simply means if A is, there is three sets A, B and C. R is a relation from set A to B and S is a relation from set B to C. Then we define a composition function, that is composition of R and S, SOR, and that is defined from set A to C. So if AC belongs to SOR, that means A is related to C with respect to function composition SOR, then it implies that A is related to B with relation R and B is related to C with relation S. And if A is related to B, on conversely, if A is related to B with relation R and B is related to C with relation S, then A is related to C with function composition SOR. Okay. So now we talk about functions. So to define function, let's suppose A and B are two non-empty sets. Okay. Then a function is a rule or mapping that is noted by F, which associates each x belongs to A to a unique member y of B. That means we take, there is a set A and there is set B, and we define a function from set A to set B. Okay, and we just take each element of set A and just map with a unique member of set B. Then this mapping, this rule from set A to B is called function and is noted by F colon A to B. Okay. So the function is defined from set A to B. We take an element from set A, each element from a set A, and just map, just assign a number, a unique member from set B to that element. And that mapping, that rule is called function. So what is domain for a function f? That is denoted by df. The set A is called domain. Function is defined from set A to B. So the set A is called domain for that function and is defined from set A to B. So the set B is called codomain for the function f and denoted by CF. So from which set we take the element is your domain and we assign another element. So the set which contain that all elements is your codomain. Okay. Next one is range of function, that is noted by RF. So what is range of function? So the set consisting of all the f images of elements of the domain A is called the range of function. Okay. So if we take the elements from the domain and we map with a unique member of element of B, so collection of all the unique member is your range set. Okay, that is also called image, f images of the element of the domain A, and that is your range set and noted by RF. Okay, some note. Okay, so a relation will be a function. So how is a relation function related to each other? A relation will be a function if no two distinct ordered pair have the same first element. So how relation is defined? Relation is defined from set A to B. It is a subset of Cartesian product of A cross B. So it is an ordered pair, and first element come from set A and second element from set B. So if no two distinct ordered pair, we just take two ordered pair and have the same first element. If we take it has an element type A, B and AC. That first element is same in two distinct ordered pair A, B and AC. Then relation will be a function. Okay, if it does not have such ordered pair. Every function is a relation, but every relation is not necessarily a function. Okay, so if there is a function, it is a relation, but every relation is not necessarily a function, because if there is a ordered pair have the same first element, then that relation is not a function. Okay, okay. So the basic difference between function and relation is that each function is a relation, because relation is a subset of Cartesian product A cross B, and if there is a certain one specific property is that if no two distinct ordered pair, that is if AB and AC, we take just two distinct ordered pair that have the same first element, AB is belongs to R and AC belongs to R, then that relation is not a function. Okay, a relation is a function if no two distinct ordered pair have the same first element. The number of function from a finite set A into finite set B is number of element B power number of element in A. So if a function f is defined from a finite set A to finite set B, and we want to calculate total number of function that we can define from that set A to B, is equal to number of element in set B power number of element in set A. Okay. So now we'll talk about different types of function. So first is one function. So how we define? Let f be a function that is defined from set A to B, where A is domain and B is codomain. Okay, then that function f is called one function, or another name is injective function if different element of A have different images in B. So how we define a function? We take each element of x from set A and map with a unique member of set B. Then it is called function. If it is another property that if different element of A have different images in B, then your function is called 1 1 function. We can understand from this diagram, we have a two set A and B, and we define a function f from A to B. A has element A1, A2, A3 and A4, and B has element B1, B2, B3 and B4. This A1, A2, A3, 4, this is your domain, and B1, B2, B3, 4 is codomain. And we take each element of set A, like we take A1, and we map with a unique member to set B. That's how we define a function. So A1 map with B2, A2 map with B1, A3 map with B4, and A4 map with B3. So that's your function. So why it is 1 1 function? The definition of 1 1 function is if different element of A have different image in B. So for all elements in A, A1 has different image B2, A2 has B1, A3 has B4, A4 has B3. No two images are same. Let's suppose if A1 map to B2 and A2 is also mapped to B2, then this is not a 1 1 function, because B2 is has the same, B2 is same image for A1 also, and B2 is also image for A2. Okay, so if each element of A has different image in B, then your function is 1 1 function. Okay. So how we can check a given function is 1 1 or not? So first method is, if fx is equal to fy, just take fx is equal to fy. What is fx and fy? So f is a function. So we just apply the function x. X is come from domain. Function is defined from set A to B, and x and y just take two element from set A, and fx and fy belongs to codomain, that is come from range. So fx and fy belongs to set B. So if we take fx is equal to fy, that means we take two images are equal. Fx is equal to fy, and it implies that x is equal to y. That means if we take two images are equal, then it implies the element is also equal. So if, then the function f is 1 1. So that's how we can prove a given function is 1 1. Just take fx is equal to fy and prove that x is equal to y. Okay, that is your method 1. Second method is based on graphical method. So function is 1 1. So if no line parallel to x-axis meets the graph of function at more than 1 point, so just draw a graph for a function. As in first figure, we draw a graph for the function fx, and the line parallel to x-axis, no line parallel to x-axis cuts the graph more than 1 point. So for the first graph, all the lines parallel to x-axis cuts at the only 1 point to the graph. Then the function is 1 1 function. In the second graph, if we draw the graph and the parallel line to x-axis, there is a line which cuts the graph at 2 points of the graph. So this function is not a 1 1 function. So there is two methods to check if function is 1 1 or not. First is just take image is equal, fx equal to fy, and prove that x is equal to y. Then your function f is 1 1. And second is graphical method. First draw the graph and sketch a line parallel to x-axis. And if all the lines cuts the graph at only once, then the function is 1 1. And if any line cuts the graph more than 1 point, then your function is not a 1 1 function. The number of 1 1 function that can be defined from finite set A into finite set B is. So how we can calculate total number of 1 1 function from a finite set A into a finite set B? The formula is of use the permutation. Here NB is number of elements in set B and NA is number of elements in set A. So if NB is greater than equal to NA, then total number of 1 1 function from set A to set B is NB, P and A. Okay. Otherwise 0. That means if NB is less than NA, then there is no 1-1 function. Okay. Next type is many-one function. So what is many-one? So as its name suggests, f is said to be many-one function if two or more element of set A have the same image in B. Okay. So if a function f is defined from set A to B, and if there is more than one element in set A that have the same element in that is assigned to same element of B, then this is not a 1-1 function. That is a many-one function. We understand by this diagram. Here A and B are two sets and the function is defined from A to B. Here A1, A2, A3, A4, A5, the element of set A, that is domain, and B1, B2, B3, B4, B5, element of set B, that is element of codomain. So here we can see A1 is mapped with B5 and A2 is mapped with B5. So for A1 and A2, there is two element, there is same image in set B, that is B5. Okay. And similar way, A3 and A4 have the same image, that is B2. So this type of function is your many-one function. Okay. If two and more element of set A have the same image in B. So we can clearly observe here, if a function from A to B is a many-one function, if it is not a 1-1 function. Okay. Now onto function. So f is said to be onto function if each element of B has its pre-image in A. So we just define a function f from set A to B. Okay. And if there is for each element in B, that is for each element in codomain, there is pre-images. There is an element in set A that is assigned to that element. Then this is called onto function. We can understand it this by this diagram. So there is two set A and B and the function is defined from set A to B. Set A is domain, set B is codomain. So set A has element A1, A2 and A3 and set B has element B1, B2 and B3. So what is the definition? If each element of B has its pre-image in A. So each element of B, first element is B1. So B1 has pre-image, that is A1. Okay. So here A1 elements of A are called pre-images and elements of B are called images. So A1 is assigned to B1. So B1 has pre-image A1. Another element of set B is B2. So B2, what is the pre-image of B2? That is A3. And last element is B3. And for B3, the pre-image is A2. So for all element, for each element of B has its pre-image in set A. So this type of function is called onto function. Clear? Next is how to check a given function is onto or not. So at first step, find the range of fx. What is range for a function? Range of function is collection of that is also on a set and it is a collection of all the images. So find the range of fx and so that the range of fx is equal to codomain of fx. That means if each element of the codomain is an image for some pre-image, then this is called onto function. Okay. Any polynomial function of odd degree is always onto function. How we can calculate number of onto function? So number of onto function that can be defined. There is a set A and the cardinal number for set A is n, and another set is also a finite set, that is B, and the number of elements set B is 2. So number of onto function from set A to B is 2 to the power n minus 2. Here n is number of elements set A and number of elements set B is 2. So that's how we can calculate total number of onto function from set A to B, where number of elements set A is n and number of elements set B is 2. If NA is greater than equal to NB, that means if we define a function f from set A to B and number of element in domain is greater than equal to number of element in codomain, then number of onto function is 0. Okay. Now, if A and B both are finite set and A has m element and B has n element, then where m is less than equal to n, because this is a necessary condition for onto function. If m is greater than equal to n, then there is no onto function. So the number of onto function from A to B is n the power m minus n c1 minus n minus 1 the power m plus n c2 n minus 2 whole power m minus dot 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 m is less than n. Okay. So this is the formula to calculate number of onto function from set A to B, where number of element in set A is m and number of elements set B is n. M should be less than n. Then this is the formula to calculate number of onto function. Okay, clear? Now next is into function. So what is into function? A function f that is defined from set A to B is called a into function if there exists at least one element in B having no pre-image in A. Okay, that is A to B is an into function if it is not an onto function. So if you remember the definition of onto function, then we easily understand what is into function. So for into function, there must be exist at least one element in B, that is there is at least one element codomain that having no pre-images in set A. Okay, that means range of function is not equal to codomain. Then the function is called into function. As in this figure, for element B4 and B5, that is the element of codomain, element of set B has no pre-images in set A. B1 is pre-image A1, B2 is pre-images A2 and A3, B3 has pre-images A4 and A5, but B4 and B5 has no pre-images. So this function is a into function. Okay. Next type is bijective function. So function f is said to be bijective function if it is 1 as well as onto. Okay. So if f is a function that is defined from set A to B, then it is a bijective function. If and only if it is 1 as well as 1 So what is 1 So we can prove 1 as if we take image are equal, fx is equal to fy, and if we can prove x is equal to y, then your function is 1 And for onto, if for each element of set B has in pre-images in set A, then your function is onto function. Okay. So if your function is 1 as well as onto, then f is a bijective function. Okay, clear? Now, if f is defined from set A to B and is bijective, then A and B have same number of elements. Okay, so it is clear from condition of 1 and onto. So if we define a bijective mapping from set A to B, then it is clear that A and B have the same number of element. Okay. So let's suppose number of element in set A is m and number of element set B is m. Then total number of bijective function from set A to B is m. That's how we calculate number of bijective function from set A to B. Now we talk about composition of function. So let's suppose we have two function, one is f, another is z, and we define a function f from set A to B, and function g defined from set B to C. So for function f, A is domain and B is codomain, and for function g, B is domain and C is codomain. So what is the meaning of f is a function from A to B? We take each element of set A and map with a unique element in set B. And for function g, we take each element of set B and map with a unique member of set C. Then this is a function g. So there is two function. Then composition of f and g. Now we compose two different function f and g, and it is denoted by GOF. So GOF is defined from A to C. So for a function composition GOF, now the domain is A and codomain is C. So function f is defined from A to B, G is defined from B to C, and GOF is defined from A to C. So for function GOF, for the composition of f and g, now the domain is A and codomain is C, and is defined as function composition GOF x is equal to G bracket fx for all x belongs to A. So how we get this? X is belongs to A because the function f is defined from A to B. So to define function fx, the element comes from the domain of f, and domain of f is A. So x must belongs to A. Okay. So that's we can define fx. Now to define g of fx, so we have to calculate g at fx at a point fx. So now fx is a must be at the domain of g. So GOF is defined only if fx is an element of domain of g. Then we can define a function combination GOF. Okay. So GOF is a function from A to C because we take an element. First elements come from set A. So it is defined on a set A, that is x. So domain is A, and the last element, the image, is come from set C, as G is defined from B to C. So if we calculate G of fx, then it is an element of set C. So domain for a function composition GOF is A, and codomain for a function GOF is C. Okay. And one important thing is, to define GOF, fx must be an element of a domain of G. That is, fx must belong to set B. Okay. Generally, GOF is not equal to f or g. So here G is composed with f is not necessarily to equal to f composed with G. So as we define here GOF, we can also define f or g. So f or g x is equal to f gx. Okay. So it not necessarily this both are equal. So function composition is not a commutative. Okay. Now we will do some question based on relation and function. Okay. So question number 1 is, if Na is equal to 4, so there are 3 sets A, B and C, and cardinal number for A is 4, cardinal number for B is 3, that is number of elements set A is 4 and number of elements set B is 3, and number of element in the Cartesian product of A, B and C, that is A cross B cross C, is 24. Then we are asked for what is the number of element in set C. So given option are 2, option B is 288, option C is 12 and option D is 1. So how we can calculate this? Okay. So what is the formula to calculate number of element in a Cartesian product? If A and B are 2 sets and number of element in set A is P and number of element in set B, then formula for number of element in Cartesian product of A cross B is PQ. So we use this formula to solve this question. Okay. So correct answer is option A. Okay, so let's solve it. We know number of element in a Cartesian product A cross B cross C is equal to, we just multiply number of element in set A into number of in set B into number of in set C, because we know that if A and B are 2 sets and number of elements set A is P and number of elements set B is Q, then total number of element in a Cartesian product is, we just multiply the current number of both sets, so we get PQ. So at total 3 sets, okay, and we take cardinal product of 3 sets, so we just need to multiply cardinal number of all these 3 sets to get the total number of element in a Cartesian product A cross B cross C. Okay. Now from the question we have Na is equal to 4, Nb is equal to 3 and number of element in A cross B cross C is 24. So just substitute this value into this relation, we get number of elements C is equal to 24 by 4 into 3. So when we simplify it, we get 2. So number of element in a set C is equal to 2. Okay, simple question. Just with the concept that how we can calculate the number of element in Cartesian product. Okay. Next question is, there is a given a relation R is equal to 3 comma 3, 6 comma 6, 9 comma 9, 12 comma 12, 6 comma 12, 3 comma 9, 3 comma 12, 3 comma 6. So relation is a subset of a Cartesian product, that is set is a collection of ordered pairs. 3 comma 3 belongs to R means 3 is related to 3 by relation R. 6 comma 12 belongs to R means 6 is related to 12 by relation R, and this relation is defined on a set A, where set A is 3 comma 6 comma 9 comma 12. Okay, so R is defined on a set A, that means relation R is a subset of A cross A. Okay, so the question is the relation is option A an equivalence relation, option B reflexive and symmetric, option C reflexive and transitive, and option D only reflexive. So to solve this question, we should know what is equivalence relation. So an equivalence relation is a relation which is transitive, symmetric and reflexive. Okay. What is reflexive? Reflexive mean if A is related to itself, for all A belongs to A, then it is reflexive. What is the meaning of symmetric? If A is related to B, it implies B is also related to A, then it is symmetric. And what is transitive? If A is related to B and B is related to C, then if A is also related to C for all ABC belongs to A, then that relation is transitive. So you just need to check all the properties. Okay. So correct answer is option C. Okay. So let's check. So for each A belongs to A comma A belongs to R is reflexive relation. This is a definition for reflexive relation. So A's come from set A. Set A is 3, 6, 9, 12. So if in a relation R, 3, 3, 6, 6, 9, 9 and 12, 12 belongs to the set R, then that set is a reflexive relation. Okay. And we can clearly see here 3, 3, 6, 6, 9, 9 and 12, 12 belongs to R. So this relation is a reflexive relation. Okay. To prove it is not a symmetric relation, what is the definition for symmetric relation? If A comma B belongs to R, but if we can show there is a really example that is B comma A is not related to R, then this is not a symmetric relation. And from this collection we can see 6 comma 12. So if we take an element from this set, that is a 6 comma 12, that is 6 related to 12, but 12 comma 6 does not belongs to R. That means 12 is not related to 6. That is AB related to R, but B is not related to R. So this is not a symmetric relation. So to check a given relation is symmetric, reflexive or not, we have to check for all pair. Okay. Now also 3 comma 6 and 6 comma 12 belongs to R. It means A comma B and B comma C belongs to R. And also we can see 3 comma 12 also belongs to R. So it satisfies the property of transitivity, that is A comma B belongs to R, B comma C belongs to R, then A comma C also belongs to R. Okay. So this relation is a transitive. So to take transitive we have to check for all pair, and we can see for each pair they satisfy the property of transitivity. Okay. As we can see, take 3 comma 3. Okay. So this relation is reflexive and transitive. Clear? So option C is the correct answer. I hope you understand. Okay, so let's move to the next question. So question number 3 is, R is a relation and it is defined as x comma y, where x and y comes from natural number, set of natural number. Okay, and it satisfies the equation, that is x square minus 4xy plus 3y square is equal to 0. So this relation is given in set builder form, where this pair x comma y belongs to the relation R if x and y is a natural number and it satisfies this equation. That is, if you take x and y to belongs to R, then it must satisfy the relation, this equation, that is x square minus 4xy plus 3y square is equal to 0, and where n is a natural number, then the relation R is, so we are asking for what is the relation R. For option A, is it a reflexive but neither symmetric nor transitive? Option B, symmetric and transitive. Option C, reflexive and symmetric. And option D, reflexive and transitive. So you just need to check, is it the relation R satisfy the property for reflexive, for transitive and symmetric. Okay. So correct option is option A. So let's solve this question. Now, what is the definition for reflexive? Set a relation is reflexive relation if for each A belongs to a set A is related to A itself. Here set A is n. We define relation on a set of natural number. So element come from set of natural number, and if each element of natural number is related to itself by this relation, then this relation is a reflexive relation. So for that, we just take x as A and y is A and substitute into this equation. We get A square minus 4A into A plus 3A square is equal to 4A square minus 4A square. So it becomes 0. So A is related to A itself. Clear? So as A is related to A itself, so this relation is a reflexive relation. Clear? Now we check for symmetric. So for symmetric, just take x is equal to A and y is equal to B. So we get A square minus 4AB plus 3B square equal to 0. So if we consider it is true, then A is related to B. Now, is it necessary to be related to A? That means if we take B square minus 4BA plus 3A square, it is not necessary to equal to 0. Clear? So this relation is not a symmetric relation. Clear? Okay. Now, for R to be transitive, what is the definition for transitivity? If A is related to B and B is related to C, then if A is also related to C, then your relation is transitive relation. So the given equation is x square minus 4xy plus 3y square equal to 0. Now we prove is it a given relation transitive or not. So x square minus 4xy plus 3y square is equal to 0. We can factor it as x minus y into x minus 3y equal to 0. So we get from x minus y equal to 0, we get x equal to y, and x minus 3y equal to 0, we get x is equal to 3y. Hence, the relation can be described as, another form to describe it as, R is equal to x comma y, x is equal to y, or x is equal to 3y. This is just another definition for the relation, another form of the definition. That is, x comma y belongs to R if either x is equal to y or x is equal to 3y, where x and y come from natural number. Okay. So relation R is not transitive. Why? Because if we take x comma y belongs to R and y comma z belongs to R, it means x is related to y and y is related to z. So it must be a form of either x is equal to y or x is equal to 3y. So for example, if x is equal to 3y, okay, and y is equal to 3z, then x is equal to 9z. In place of y, just substitute 3z in x equal to 3y, we get x equal to 9z, and which is not of the form, neither it is x equal to z nor is x is equal to 3z. So x comma z is not in R. X is not related to z with respect to R. So this transitive property fails. So given relation is not a transitive relation. So relation is reflexive but not symmetric and also not satisfy the property of transitivity. Clear? Any doubt? Okay. Next question is question 4. If gx is equal to 1 plus root x, function gx is defined as 1 plus root x, and function composition f of gx is defined as 3 plus 2 root x plus x, then fx is equal to, given option are 1 plus 2x square 2 plus x square, 1 plus x or 2 plus x. So here two functions given. One is gx, that is 1 plus root x, and function composition is given. F of gx, 3 plus 2 root x plus x. And it is asking about what is your function fx. Okay. So let's calculate it. Correct answer is option B. So let's solve together. So given function gx is 1 plus root x. Okay. And f of gx is 3 plus 2 root x plus x. Consider it as equation number 1. Now, in place of gx, we just substitute 1 plus root x. So we get f 1 plus root x is equal to 3 plus 2 root x plus x. Okay. Now, we have to calculate fx. So consider 1 plus root x is equal to y. So when we simplify it, we get x is equal to y minus 1 whole square. Now, if we replace 1 plus root x with y, we get fy is equal to 3 plus. Now put in place of x, y minus 1 whole square. So we get 3 plus 2 into y minus 1 plus y minus 1 whole square. Okay. So when we simplify it, we get fy is equal to 2 plus y square, and just y just a variable. So we can replace it with x. So fx is equal to 2 plus x square. So that's how, by using the function composition and one definition of function gx, we can calculate function fx. Clear? Okay. Question number 5 is, there is a function fx defined as ax plus b, and function gx that is defined as cx plus d. A is not equal to 0 and c is not equal to 0. Clear? Assume a is equal to 1 and b is equal to 2. Okay? If the function composition f of gx is equal to g of fx for all x, what can we say about c and d? Okay? So option are c and d both arbitrary, c is equal to 1 and d is arbitrary, c is arbitrary and d is equal to 1, c is equal to 1 and d is equal to 1. So we have to use this given information, that is a is equal to 1 and b is equal to 2, and another information is f of gx is equal to g of fx. Okay, and we have to conclude information about c and d. So correct option is B. So let's solve it. So what is f of gx is equal to, as we know the definition of composition of function, so f of gx is equal to f gx. The definition of gx is cx plus d. So just put, and definition of fx is ax plus b. So in place of x, replace it with by cx plus d. So we get a into cx plus d plus b. And when we calculate g of fx, that is z of fx, what is the definition of fx? Ax plus b. So just put in place of x by x plus b in the definition of gx, we get c into ax plus b plus d. So it is given that f of gx is equal to g of fx. So we get cx plus d plus 2 is equal to cx plus 2c plus d. So when we compare, as already given, a is equal to 1, b equal to, so we just put into the above equation, we get cx plus d plus 2 is equal to cx plus 2c plus d. So when we compare it, we get c is equal to 1. Okay, as cx plus d plus 2, so 2 is equal to 2c, so c must be 1. Then this both is equal, and there is no restriction on d, so d is arbitrary. So correct option is option B, that is c is equal to 1 and d is arbitrary. Okay. Now, question number 6 is R is a relation from set is 11, 12, 13 to 8, 10, 12. Okay, there is two test set and we define relation from set 11, 12, 13 to 8, 10, 12. Defined by, what is the definition of relation? Y is equal to x minus 3. So if y and x satisfy this equation, then y is related to x. Okay, then we are asked for R inverse. Is it option A, that is 8, 11, 10, 13, or set B 11, 18 or 13, 10, or set C 10, 13, 8, 11, or D none of this. Okay, so let's check which option is correct. It's A or anything else. Okay, so correct answer is option A. Correct. Very good. So let's check. As relation R is defined from 11, 12, 13 to 8, 10, 12. Okay, and defined by, what is the definition? Y is equal to x minus 3. So y is equal to x minus 3. So it implies x minus y is equal to 3. So x is related to y. X come from the set 11, 12, 13 and y come from the set 8, 10 and 12. These both are related if and only if the difference between them is 3. That is your definition. So relation R is 11 and 8 because the difference between 11 and 8 is 3. So 11 is related to 8 by this definition. 11 come from the set first set and 8 come from the second set. And 13 comma 10 because the difference between 13 and 10 is again 3. So this 13 and 10 are related. Okay. So we have to find R inverse. So what is R inverse? If A is related to R with relation R, then with respect to R inverse, B is related to A. So if 11 is related to 8 with relation R, then 8 is related to 11 with R inverse. If 13 is related to 10 with relation R, then 10 is related to 13 with relation R inverse. Clear? Okay. So correct option is option A. Very good. Next question is, let R be a relation defined by R is equal to 4, 5, 1, 4, 4, 6, 7, 6 and 3, 7. Then what is R inverse composition with R? Okay, is it 1, 1, 4, 4, 4, 7, 7, 4, 7, 7, 3, 3, or option B 1, 1, 4, 4, 7, 7, 3, 3, or option C 1, 5, 1, 6, 3, 6, or none of the above. So for this we have to calculate R inverse, then we have to find composition R inverse with R. Okay, so let's solve it. So correct answer is option A. To find R inverse, we just reverse. If 4, 5 belongs to R, then 5, 4 belongs to R inverse. If 1, 4 belongs to R, then 4, 1. In similar way, 6, 4 belongs to R inverse, 6, 7 belongs to R inverse, 7, 3 belongs to R inverse. So that is your set R inverse. Now you have to find element of R inverse composition with R. So now as 4, 5 belongs to R and 5, 4 belongs to R inverse, then 4, 4 belongs to R inverse composition with R. If AB belongs to R and BC belongs to R inverse, then AC belongs to R inverse composition with R. Okay, that is the definition of composition of relation. In a similar way, if 1, 4 belongs to R and 4, 1 belongs to R inverse, then 1, 1 belongs to R inverse composition R. Okay. And if 4, 6 belongs to R and 6, 7 belongs to R inverse, then 4, 7 belongs to R inverse composition R. And if 7, 6 belongs to R and 6, 7 belongs to R inverse, then 7, 7 belongs to R inverse composition R. And if 7, 6 belongs to R and 6, 4 belongs to R inverse, then 7, 4 belongs to R inverse composition R. And if 3, 7 belongs to R and 7, 3 belongs to R inverse, then 3, 3 belongs to R inverse composition R. So we just use the definition of composition of relation, that if A, B belongs to R and B, C belongs to R inverse, then A, C belongs to R inverse composition R. So the set for R inverse composition R is 1, 1, 4, 4, 4, 7, 7, 7, 7, 4 and 3, 3. Okay, so this is your set R inverse composition R. Okay, clear? So that's all for today. So if everything is clear, I hope the session is helpful. Okay, thank you.
Hello students, in today's lecture we are going to learn about motion in a straight line theory part. This is our disclaimer. So firstly we will see the trend analysis of the chapter motion in a straight line in JEE Mains. So if we talk about the overall weightage, so we can say it is 2.9%. And if we talk about the yearly question distribution, then we can say last year, or we can say in 2024, the topic question asked from kinematic equation for uniformly accelerated motion, and the total number of questions 1. If we talk about their difficulty, so we can say difficulty level is average. Similarly, in 2023, question asked from relative velocity. Okay, and question asked from uh, relative velocity, and number of questions 1, and their difficulty level is easy. Similarly, in 2022 and 2020. All right. So this is our yearly question distribution. So in today's lecture, we will cover first frame of reference, then motion in a straight line, then uniform and non-uniform motion. Here we will also see the difference between uniform and non-uniform motion. Then we will learn uniformly accelerated motion. After that, elementary concept of differentiation and integration for describing motion. And last, we will discuss some graphs. Clear, everyone? So let's start with frame of reference. So here question arises, what is the meaning of frame of reference? So if we talk about the frame of reference, then we can say it is a coordinate system that includes both space coordinates and time coordinates, so that we can specify where a body was at what time. The most common reference frame we use in Cartesian frame of the reference. It means Cartesian frame of reference is the commonly used, in which we conclude x, y, z and t. Here t is the time. When we add t to it, it becomes our frame of reference. Clear? So this is important concept. Manisha, Chandana, clear? All right. So we have a two type of frame of reference. First, inertial frame of reference. Second, non-inertial frame of reference. So firstly, we will discuss about the inertial frame of reference. A frame of reference that is either at rest or moving with a constant velocity. Here constant velocity is an important word. So listen carefully. Constant velocity in a frame of reference is called a frame of reference with constant velocity is inertial frame of reference. And the important thing of this frame of reference, we can say Newton's first law applies in an inertial frame of reference. This means whatever physical activity occurs within it, Newton's first law of motion will apply to it. It means we can say the inertial frame of reference depends on Newton's first law of motion. Yes or no? Everyone. Second, we have a non-inertial frame of reference. So in non-inertial frame of reference has some acceleration. This acceleration can be small or large, but acceleration is present there. All right. Now this means if we take a frame of reference that is moving with some acceleration, then that type of frame of reference is called non-inertial frame of reference. I think the definition of the non-inertial frame of reference is clear. The main important point here is non-inertial frame of reference independent of Newton's laws of motion. It means Newton's law of motion do not apply in a non-inertial frame of reference. Clear? So if you want to difference between inertial frame of reference and non-inertial frame of reference, we can say inertial frame of reference depends on Newton's first law of motion, whereas non-inertial frame of reference independent of Newton's law of motion. Alright, this is the common difference point between or we can say general difference point. Clear, Chandan? Now the topic is motion in a straight line. As the name suggests, straight line. Straight line means one dimension. Alright. So what is the meaning of straight line? Think about it. This is very important concept for the exam. So if we talk about the motion in a straight line, we can say the motion of any point object in a straight line is called one dimensional motion. So what happens in that type of motion? So we can say during this type of motion, point object occupies a definite position on that path at every instant of time. Alright. So in motion in a straight line consists of different terminologies like distance, displacement, acceleration, velocity, retardation. Alright. So all these terms are very important. We will see each term one by one. Alright. Any doubt? Yes or no? Alright. Now let's see first term, that is distance, and second term is here displacement. So if we talk about the distance, so how we can define? So we can say distance is the total length of the path traveled by a particle in a given interval of time. It means what? Suppose we traveled from position 1 to position 2. So there is a some distance now, and there is a time interval. So the distance here is a scalar quantity. It means it has only magnitude. There is a no direction. If we talk about the unit, so we can say SI unit is meter. The second term is displacement. Displacement is an important term. It is defined as the total length covered by a particle within a given interval of time. The important thing here is this: displacement represents the actual path traversed by the particle. It means it depends on initial and final position. We will understand distance and displacement by using a figure. Alright. So look at here. Here x is the horizontal axis, x-axis, and horizontal axis is x-axis and vertical axis is y-axis. Now we have two particles, first at point A, second at point B. Alright. Now the distance of point A from origin is r1 and the distance of point B from origin is r2. Here r1 and r2 are the position vectors. Okay, R1 and R2 are the position vectors. Now, if we want to calculate the displacement, so just subtract OB vector minus OA vector, or we can say R2 vector minus R1 vector. So the resultant is delta R. Here delta R is the displacement. So look at here, there is a 2 point, A point and B point. It means displacement depends on A point and B point. If our initial position and final position is same, suppose you are moving from A point to B point, then after some time you are again moving from B point to A point. In that case, we can say your initial and final position is same. Yes or no, Akshay? In that case, the initial and final position is same. So we can say that displacement should be 0. It means displacement should be 0. So here we directly say that displacement is a path independent. It depends on initial and final position. Whereas distance is a path dependent. Distance is the total length of the path traveled by a particle in a given time. So the difference between displacement and distance is clear? Manisha, Akshay, Chandana, everyone is clear? Here distance is a scalar quantity, but displacement is a vector quantity. Alright, because it has both magnitude and direction. Alright, this concept might look simple to you, but question actually has been asked from this concept. Okay, so the displacement here is delta R, R2 minus R1. Now for motion between 2 points, A point and B point, the displacement is a single valued. Alright, while this distance depends on actual path, and so you can have many values. Alright, so magnitude of displacement can never be greater than distance. It means the magnitude of distance is always greater than, or we can say equal to, displacement, because distance is a path traveled by a particle, total length of the path traveled by a particle, whereas, listen carefully, whereas displacement is the shortest distance, as shown in the figure. You can see, look at here. So the actual path, if we talk about the distance, this is there is a too much curves, more than one curves. All right, and that if we talk about the displacement, so this is the shortest distance between initial and final positions. So initial position A point, final position B point. So you can easily differentiate the difference between displacement and distance. Alright, so if we talk about an example, suppose, alright, you are going from your home to your school. Alright, so in that case, suppose the distance between your school and home is 1 kilometer. So alright, 1 kilometer, and you are going to home to your school. Then after some time you are going school to home. Then what is the value of distance and what is the value of displacement? Think about it. So the distance is 1 kilometer. So we can say the total distance is 2 kilometer. Yes or no? And displacement is what? Tell me. 0. Alright, displacement is 0. Why 0? Because distance is path dependent, whereas displacement is path independent. It depends on the initial and final position. So in the case of school and house, the initial position is house, or final position is also house. So we can say the displacement should be 0. Clear everyone? Yes or no? Sai Kirat. Clear? All right. Let's see next point. The next is speed and velocity. All right. If we talk about the speed, so we can say speed is defined as the total path length or actual distance covered by the time taking by an object. So if we want to calculate the speed, so we have a formula, that is speed equal to distance upon time taken. Distance upon time taken. Speed is a scalar quantity. It means it has only magnitude. There is no direction. And if we talk about the SI unit, so we can say SI unit is meter per second. Yes or no? So how we can say the SI unit is meter per second? Think about it. So we can say the distance is measured in meter and time is measured in second. So directly from this relation, we can say the SI unit is meter per second. Now next is average speed. All right. So average speed. So average speed, the formula is total distance traveled divided by delta t. All right. So there is just some more formulas, and these formulas are very important. So please note down, everyone. All right. So first is average speed in terms of harmonic mean. All right. Now when a body travels equal distance with speeds v1 and v2. So here we have a two speeds, v1 and v2. The average speed is the harmonic mean of two speeds, and the formula is 2 divided by v equal to 1 divided by v1 plus 1 divided by v2. Alright, so this formula is very important. 2 by v is equal to 1 divided by v1 plus 1 divided by v2. So please note down. Okay. Next one, arithmetic mean. When a body travels for equal time with speed v1 and v2, the average speed v is the arithmetic mean of two speeds. So we have a two speeds, v1 and v2. Yes or no? We have two speeds, v1 and v2. So the formula is v average equal to v1 plus v2 divided by 2. All right. So these formulas are very important. Now the next term is velocity. So here question arises, what is velocity? Think about it. So we know velocity is a vector quantity. All right, vector quantity. It means it has both magnitude and direction. So we can say velocity tells us how fast an object is moving. Okay, and in what direction. So we know velocity has magnitude and direction. So it tells us how fast an object is moving. So to calculate it, we have a formula, that is displacement divided by time interval. So displacement divided by time interval gives us velocity. Clear everyone? Manisha, Sai Kirat, Akshay, clear? Chandana, all right? Any doubt here? If you have doubt any, please ask. Yes. All right. Wait a minute. Now, uh, we will talk about the average velocity. All right. So average velocity is equal to total displacement divided by total time taken. Clear? So displacement is a path independent. It depends on final or initial position. So what will be the term of displacement? So we can say final position x2 and initial position x1. Yes or no? So it will be x2 minus x1 and time interval t2 minus t1. है ना? So it will be delta x divided by delta t. Change total distance, total displacement delta t, and total time taken is delta t. Here x2 and x1 is the positions of a particle at the time t2 and t1 respectively, with respect to a given frame of reference. All right? Yes or no? Clear? Now, for a moving body, speed can never be negative or zero, while velocity can be negative or negative and zero. Why? Because speed is a scalar quantity and velocity is a vector quantity. Now, we will talk about the instantaneous speed. Instantaneous speed in the form of average speed, the formula is v is equal to limit delta t approaches 0, delta s divided by delta t equal to ds upon dt. Here, uh, delta t approaches 0. It means delta t is not equal to 0 but approaches to 0. All right. So the formula is ds upon dt. The instantaneous velocity v of a moving particle is v equal to limit delta t approaches 0 delta x upon delta t equal to dx upon dt. All right. Now, this concept might look simple to you, but this question has actually been asked in the exam. So please note down every formulas. At a particular time, the we can say to calculate the slope, uh, to calculate the uh, calculate the velocity, we will use the concept of slope. All right. Any doubt here? If you have any doubt, please ask. Okay. Any doubt? Manisha, VK? All right. Now, let's see uniform and non-uniform motion. Okay. And from uh, from this concept, question asked from l- last year JEE main exam. All right. So if we talk about the uniform motion, so we can say uh, in uniform motion, uh, object maintains constant velocity. Object maintains constant velocity, meaning it covers equal distances in equal intervals of time, no matter how small those intervals are. All right. Yes, please ask in chat box, Manisha. All right. So here we can say in uniform motion, object maintains constant velocity, or we can say equal distance in equal interval of time. Clear? So this is the uniform motion. All right. Clear? Now, uh, suppose we took equal displacement. Listen carefully. We took equal displacements such as 2 meters, 2 meters, 2 meters, and 2 meters. But it took 1 second to cover first 2 meters, then 2 second for next 2 meters, then 3 second for the next 4 second. That is called non-uniform motion. All right. It means we can say in non-uniform motion, object covers equal distance in unequal intervals of time. Okay? Regardless of how small those intervals may be. All right. So if we want to differentiate difference between uniform and non-uniform motion, we we directly say that in uniform motion, object covers equal distance in equal intervals of time, whereas in non-uniform motion, object covers equal distance in unequal intervals of time. Clear? Uniform motion and non-uniform motion is clear, everyone? Okay. Now next term is acceleration. So here question arises, what is the meaning of acceleration? So we can say the acceleration of an object defines the rate of change of its velocity. Rate of change of velocity. It is a vector quantity. All right. It is a vector quantity. It means having both magnitude and direction. And unit is meter per second square. It can be positive or negative. Yes. In non-uniform motion, object covers equal distance in unequal interval of time. All right. So this is the concept of acceleration. Now, if we talk about the average and instantaneous acceleration. So if the velocity of particle at instant t is v1 and at instant t2 is v2. In that case, average the formula of average acceleration is equal to v2 minus v1 divided by t2 minus t1. So it is equal to delta v divided by delta t. And if we want to calculate instantaneous acceleration, so listen carefully. Instantaneous acceleration means limit delta t approaches to 0, but delta t is not equal to 0, just approaches to 0. So a equal to limit delta t approaches 0, delta v divided by delta t, alright, is equal to dv upon dt. Alright, so this is the formula of instantaneous acceleration. Clear this? Clear this? Acceleration is clear? Okay. Now we will understand uniformly accelerated motion. So in uniformly accelerated motion, we can say a motion in which change in velocity in each unit of time is constant is called uniformly accelerated motion. So for uniformly accelerated motion, acceleration is constant. Suppose there is an object uniformly undergoing uniformly accelerated motion. So for this, we need to find out the what is the equation of motion will be. All right. So here we have some equations of motion. You know, first equation of motion v equal to u plus at. Second equation of motion s is equal to ut plus half at square, and third v square equal to u square plus 2as. Okay. So these are the three equations of motion. Now here u is equal to initial velocity, v equal to velocity at time t, and s is equal to displacement of particle at time t. So equations of motions, I think you are already learned in previous classes. Yes or no? Now there is some important concept. So listen carefully, everyone. Equation of motion, or we can say equation of uniformly accelerated motion under gravity. Okay, in that case, what will happen? So under gravity, under gravity means suppose you throw a ball, like suppose you throw a pen, okay, in upward direction. Look at here, you throw a pen in upward direction. So when we throw a pen in upward direction, yes, so the direction is vertically upward. Direction is vertically upward. What then? What will be the direction of gravity? Gravity always acted vertically downward. It means the direction of pen vertically upward and the direction of gravity vertically downward. It means what? It means both are anti-parallel, or we can say both are opposite to each other. Yes or no? If both are opposite to each other, so we can say G, here we can take it as a negative with negative sign. So when G gravity equal to minus G, so just put the value in the equation of motion, you will be get V equal to U minus GT. All right. And second is second equation, uh, S is equal to UT minus half AT square. Here S is the displacement, H is the height. Both shows the same thing here. Height, the measured height or measured distance. All right. And the third one, V square equal to U square minus 2GH or 2AS. Clear? The uniformly accelerated motion concept is clear. All right. So this is our uniformly accelerated motion. Now we will study elementary concept of differentiation and integration for describing motion. So here at an instant t, suppose at instant t, the body is at point p, x, y, z. So p is the point p. and xyz is the coordinates. As we already told you, the frame of reference, there is a coordinate system, so x, y and z. Thus the velocity along x-axis, if we talk about the velocity along x-axis, so vx, this is the symbol of that represent velocity along x-axis. So vx is equal to dx upon dt, rate of change of position. Yes or no? Dx upon dt is what? This is the rate of change of position along x-axis. So rate of change of position is what? That is velocity. All right. Next is what will be the acceleration? So we know acceleration is rate of change of velocity. If we talk about the acceleration along x-axis, then what? Then what will be the formula? So ax is equal to dvx upon dt. All right. And now think about the velocity along y-axis. Then what? Then what will be the equation? What will be the formula? So velocity along y-axis, it will be vy equal to dy upon dt. And what will be the acceleration? So we can say acceleration along y-axis is ay equal to dvy upon dt. All right. So these are the concepts that is related to velocity, acceleration. All right. Similarly, we can calculate velocity and acceleration along z-axis, that is dz upon dt, and acceleration along z-axis is vz upon dt. All right. Any doubt here? Now, if the body is accelerating, all right, let's say there is a body that is accelerating and we need to find x, y and z. So if ax is variable, it means it changes. All right. So in that case, x is equal to what? X is equal to integration vx dt. Vx dt. How? Look at here. The second line. Vx is equal to dx upon dt. So cross multiply, you will be get vx dt equal to dx. So integrate both sides. So integration of dx is what? That is x. So x is equal to integration vx dt. All right. Look at here, this one. Dvx integration dvx is equal to integration ax dt. So we know integration of dvx is what? That is v. So vx is equal to integration ax dt. The first line is clear for an accelerating body? Yes or no? Tell me. This concept might look simple to you, but this question has actually been asked in the exam. So this is clear. The VK, Manisha and Akshay. Everyone clear? If yes, uh, thumbs up. All right, very good. Very good, Akshay. Okay, okay, very good, VK. Now, uh, if AY is variable, okay, if AY is variable, so y equal to integration Vy dt. So again here, we take the in the fourth line, first, second, third and fourth line. Again here, just take the cross multiply and you will be get the y equal to integration Vy dt. All right. So it will be integration dvy is equal to integration ay dt. So this is the just simple term that comes from the above relations. Third one, similarly, if az is a variable, z equal to integration vz dt and integration dvz equal to integration az dt. All right. So here these concepts are very important for the exam. Also, distance traveled by a particle is s, that is equal to integration v dt, mod of v into dt. And first, x component of the displacement is delta x is equal to integration vx dt. And second is here we can say y component of displacement is delta y equal to integration vy dt. And third one, z component of displacement delta z equal to integration vz dt. All right. Now we will learn about the graphs. Okay, such as its position, velocity, and acceleration graph. So first, position time graph. So the slope of tangent drawn to the graph at any instant of time gives the instantaneous velocity. All right. So if we draw the tangent on position time graph, so it gives us instantaneous velocity at that instant. ST graph cannot make sharp turns. All right. There is absence of sharp turns. So different cases of position time graphs. The first here xt graph. xt graph. Look at figure. xt graph. So here uh, on y axis s and on x axis t. So first suppose at rest when the object is stationary. When an object is at rest, its position does not change with time. Alright. So its graph is a straight line, or we can say straight horizontal line parallel to time axis, or we can say x axis, as shown in the figure. The gradient of the graph is 0. So slope equal to v equal to 0, that is equal to v equal to 0. So slope equal to plus minus 1. Yes or no? So velocity is 0 because object is not moving. Second is uniform motion. So when an object is in uniform motion, it covers equal distances in equal intervals of time. So the line should be straight line. Slope equal to constant. So if the slope is equal to constant, v equal to constant. If v equal to constant, a equal to 0. Clear? Because acceleration is what? It is the rate of change of velocity. Now, uniformly accelerated motion. So with t equal to 0, s equal to 0 at t equal to 0. So then what will happen? So here initial velocity is 0 and at t equal to 0, the velocity should also be 0. So we observe that here the initial the graph slope of st graph at t equal to 0 is equal to be should be 0. So it will be increasing like this, continuously increasing. All right. Second, uniformly accelerated motion with u is equal to not equal to 0, but s equal to 0 at t equal to 0. So slope of st graph gradually increases. All right. Now velocity time graph. So the slope of tangent drawn on the graph gives instantaneous acceleration. So in position time graph, slope gives us velocity, but in velocity time graph, slope gives us acceleration. I think the main difference is clear. Yes or no? So area under VT graph with time axis gives the value of displacement. So the VT curve cannot take sharp turns. So here, yes, we will provide Praneeth Kumar, we will provide, don't worry. So there is a different cases for uniform motion, uniformly accelerated motion with u equal to 0 and s equal to 0, and uniformly accelerated motion with s u is not equal to 0 but s equal to 0 at t equal to 0. So this is the uh, explanation in the form of table. Okay, so vt graph, v increases, the main feature of the graph theta equal to 0 degree. Okay, and v increases, it means v equal to 80. So for this case, and v equal to u plus 80 when u is not equal to 0. All right. Now, next case, for non-uniformly accelerated motion, the vt graph look like this, and for non-uniformly decelerating graph look like this. So here slope of vt graph increases with time, theta is increasing, so the acceleration is increasing. Okay, and in second one theta is decreasing, so acceleration decreasing. Clear? Thank you for your attention. Now, within 1 or 2 minutes, we will solve practice questions or previous year questions based on these concepts. So, are you ready for practice questions? Yes or no? Everyone, are you ready? So, students, now we will solve some practice questions based on motion in a straight line. Are you ready? This is our disclaimer. So, here we will solve some practice questions based on motion in a straight line. So, our first question. So, look at here. An aeroplane flies 400 meter from north and then flies 300 meter south. It means firstly flies 400 meter north and then flies 300 meter south, and then flies 1200 meter upwards. The net displacement is what? So here you have to calculate the net displacement in this question. The given options: option A 1200 meter, option B 1300 meter, option C 1400 meter, and option D 1500 meter. So which one is correct? Think about it and please solve this question. You have some time. Everyone. Yes, please. Yes, please solve. So which one is correct? Manisha, Sai Kirit? Yes. Which one is correct? Think about it. Okay, let's see the solution. Here, the correct option of this question is B, A. So your option is incorrect. So C, correct as a solution. So according to question here, aeroplane flies 400 meter from north and then flies 300 meter south and then flies 1200 meter upwards. So question ask about the net displacement. I think question is clear. So according to question, there is a, a two-dimension motion, vertical motion and horizontal motion. So firstly, we calculate the uh, overall given terms. So the aeroplane moves 400 meter uh, north and 400 meter north and 300 meter south and 1200 meter upwards. So to calculate the net displacement in the north-south direction, the net displacement in the north-south direction can be calculated using given terms. So it will be displacement north 400 meter, displacement south 300 meter. So net displacement north-south direction is 400 meter minus 300 meter, that is equal to 100 meter. Alright, and upward displacement is 1200 meter. So to calculate the net displacement, the formula is under root 100 square plus 200 square. Alright, so just solve it and you will be get net displacement 1204.15 meter. It is approximately 1200 meter. This is clear. Here to solve the net displacement, we use the Pythagorean theorem to find the resultant displacement. Okay. Yes or no? Next one. The correct statement from the following is what? So there is some options and you have to find out the correct statement. So listen carefully. First, A is a body having zero velocity will not necessarily have zero acceleration. B, a body having zero velocity will necessarily have zero acceleration. C, a body having uniform speed can have only uniform acceleration. And D, a body having non-uniform velocity will have zero acceleration. So which option is correct? So think about it and solve it. You have some time, everyone, and tell me which one is the correct option. You have to find out the correct statement only. That's it. So please try to solve. Praneet Kumar, Manisha, Sai, Kirat, VK, and everyone. Please solve. So which one is correct? Yes. You have some time to solve this. After that, we will solve. We will solve this question. Which one is correct? So correct option is A. All right. Let's see the solution. Listen carefully. When a body is projected vertically upwards, all right, suppose we have a body, suppose we have a pen. So this pen is projected vertically upwards. So at the highest point, suppose this is the highest point of its motion. So at the highest point, the velocity of the body becomes 0. All right, the velocity of the body becomes 0, but acceleration is not 0. All right. So because there is a gravity that is acted vertically downward. All right. Okay. Now, next question. A vehicle travels half the distance L with speed v1 and the other half with speed v2. Then its average speed is what? So in this question, you have to find out the average speed, and this is very easy question. So please solve this, and I expect the answer from your side. So the given options: option A, v1 plus v2 divided by 2; option B, 2v1 plus v2 divided by v1 plus v2; and option C, 2v1 v2 divided by v1 plus v2; and option D, 2 into v1 plus v2 divided by v1 into v2. So which option is correct? Please answer. Swati, Manisha, Sai, Kiran, Akshay, everyone. So this is a very basic concept, but uh, this concept might look simple to you, but question from this concept actually has been asked. So which one is correct? So correct option is C. Very good, Swati and Manisha. Your options are correct. So let's see the solution. Now, uh, according to question, the vehicle travels for half of the distance L with speed v1. It means L by 2 travel with distance v1, whereas half of the distance traveled by v2. It means again travel L by 2 with speed v2. So first, the vehicle taking that time t1, and second half time taking is t2. So the time taken to the travel first half distance t1 equal to L by 2 divided by v1. Yes or no? So we know when we solving this, you will get L divided by 2 into v1. Similarly, the time taken to travel second half distance t2 equal to L by 2 divided by v2. So it will be L divided by 2 v2. So to find out the average speed, firstly we will calculate the total time. So total time is what? T1 plus T2, and we know the value of T1, that is L divided by 2v1, and we know the value of T2, that is L divided by 2v2. All right. So total time is equal to L divided by 2v1 plus L divided by 2v2. So uh, just taking here L by 2 is common, so it will be L by 2 into 1 divided by v1 plus 1 divided by v2. Now we know the formula of average speed. Yes or no? So we know average speed is equal to total distance upon total time. So just put the value. So you will be get L divided by L by 2 into 1 divided by V1 plus 1 divided by V2. So average speed equal to 2 into V1 into V2 divided by V1 plus V2. So this is our correct option. Clear? This question is clear? Everyone? Any doubt? Next one. This is again a simple question. All right. This type of question build your problem solving skill. So you need to take practice more again and again and again. So question is, a particle moves uh, along the sides AB. A particle moves, suppose A to B and B to C and C to D. All right, of a square of side 25 meter. So we have a square and their side is 25 meter with a velocity of 15 meter per second. So here you have to find out the its average velocity. What is the average velocity? Given options, option is 5 meter per second, option B 7.5 meter per second, option C 10 meter per second, and option D 15 meter per second. So which one is correct? Think about it and please solve. All right, this is very simple. You have to you need to use the formula of average velocity. That's it. You know what is the formula? Total displacement upon total time. Yes or no? So use the formula and solve it. Everyone. Yes, which one is correct? Okay, let's see the solution. The correct option is A. Very good, Manisha. So here you have to find out the average speed. So we know the formula of you have to find out the average velocity. So we know the formula of average velocity, that is total displacement upon total time taken. So just put the value of total displacement and total time taken. So total displacement is 25 and total time taken is 75 divided by 15. So when we solving this, you will be get 25 into 15 divided by 75, which is equal to 5 meter per second. All right. Next one. So in this question says that a body sliding down on a smooth inclined plane slides down 1 by 4th of the plane's length in 2 seconds. It will slide down the complete plane in how much second? So here you have to find out the time. Given options, option A 4 second, option B 5 second, option C 2 second, and option D 3 second. So think about it and try to solve. Yes. So correct option is A. As here u equal to 0 and A is a constant. So we will put the given values in the formula. S is equal to ut plus half at square. In that case, the equation will be L by 4 equal to 1 by 2 A into 2 square, and let this equation first. Similarly, second one, when we will put the values, it will be L equal to 1 by 2 at square, and let this equation second. So on dividing equation second by first, we get 1 divided by 1 by 4 is equal to t square divided by 2 square. So t square equal to 2 square into 4. So t square equal to 16. 2 the square of 2 is 4 and 4 into 4 16. So it will be 4 second. All right. Three particles P, Q and R are situated at corners of an equilateral triangle of side length D. At t equal to 0, they started to move such that P is moving towards Q. P is moving towards Q. And Q is moving towards R and R is moving towards P at every instant. How much time in second will they meet each other? So here you have to find out the time. After how much time will these three meet? So given options, option A d by u, option B 2d divided by 3u, option C 2d divided by under root 3u, and option D d divided by under root 3u. So which option is correct? Yeah, please try to solve this question. You have to find out the how much time will these three meet. Yes, everyone, tell me. Manisha, Akshay, VK, and try to solve this question. So correct option is B. So the person at point P, here this is the point P, will travel at a travel a distance PO, P to O. O is a centroid with velocity along PO. So here PO equal to U cos 30 degree. All right, U cos 30 degree. So when we put the value of U cos 30, so it will be we can say uh, PO equal to PV sec 30. Why? Because here PO divided by PV equal to sec 30. So just put the value PV and sec 30, you will be get D divided by root 3. So time of meeting T equal to distance divided by velocity. So distance is D divided by root 3 and velocity U cos 30. So just solve it and you will be get T, that is 2D divided by 3U S. A body is thrown vertically upwards in air. When air resistance is taken into account, the time of ascent is T1 and time of descent is T2. Then which of the following is true? So here you have to find out the given which one is the correct option, A, B, C or D. Think about it and try to solve. So correct option is B. So when a body is thrown up, listen carefully, its velocity goes on decreasing as air resistance is small. When a body falls down, its velocity goes on increasing as air resistance is large. So T2 is increases. A stone falls freely from rest and the total distance covered by it in the last second of its motion equals the distance covered by it in the first 3 seconds of its motion. The stone remains in the air for what? Given option 6 seconds, 5 seconds, 7 seconds and 4 seconds. So which one is correct? Yes. So correct option is B. Very good. So let's look at this equation. So Sn equal to U plus G by 2 into 2n minus 1. This is Sn which is the distance in the nth second. So according to given terms, just put the values. Sn equal to 0 plus G by 2, 2n minus 1. So from S is equal to ut plus half at square. Distance traveled in the first 3 seconds, S3 equal to 0 into 3 plus 1 by 2 G into 3 square. So when we solving S3, you will be get 9 by 2 G. This is simple mathematical terms. Just you need to calculate it and you will be get the S3. So and according to question, S3 equal to Sn. So just put the value of Sn and S3. So G by 2, 2n minus 1 equal to 9 by 2 G. So when we comparing or solving, you will get 2n minus 1 equal to 9. So 9n equal to 5 seconds. It means the stone remains in the air for 5 seconds. Clear? The motor of an electric train can give it an acceleration of 1 meter per second square and brakes can give a negative acceleration of 3 meter per second square. The shortest time in which the train can make a trip between two stations 1 to 1.5 meter apart is what? So here you have to find out the shortest time. First, A 113.6 second, option B 56.9 second, option C 60 second, and option D 55 second. So which one is correct? Yes, Manisha, Swati, and Sai Kirat. Which one is correct? Think about it and solve it. So correct option is B. Here, let S1 be the distance traveled by the train moving with acceleration 1 meter per second square. All right. And for time t1 and s2 be the distance traveled by the train moving with retardation 3 meter per second for time t2. Now, if v is the velocity of the train after time t1, then v equal to 1 into t1. So let this is equation first. So it will be s1 equal to 1 by 2 into 1 into t1 square. So it will be t1 square divided by 2. Also, v equal to 3t2 equal to v equal to 3t2. So let this is equation third. Now we know s2 equal to v2 vt2 minus 1 by 2 into 3 into t2 square. So s2 equal to t1 t2 minus 3 by 2 t2 square. So solving this from equation first and second, we get t1 equal to 3t2 or t2 equal to t1 by 3. So s1 plus s2, it will be s t1 square by 2 plus t1 into t1 divided by 3 minus t 3 by 2 into t1 square by 9. So when we solving this, so this is just mathematical calculation. So when we solving, you will get 2 by 3 t1 square. So it will be 1215 equal to 2 by 3 t1 square. So t1 equal to under root 3 into 1215 divided by 2. So t1 equal to 42.69 second. The total time is t1 plus t2. So just put the value, you will be at 56.9 seconds. I think this is clear. All right. And the last question of the today's lecture. First question is: a train is moving along a straight path with a uniform acceleration. Its engine passes a pole with a velocity of 60 km per hour and passes across the same pole with a velocity of 80 km per hour. The middle point of the train will pass the same pole with a velocity what? So here you have to find out the velocity. Given option 70 km per hour, option B 70.7 km per hour, option C 65 km per hour, and option D 75 km per hour. So which one is correct? Yes. All right. Please solve it. So correct option is B. So we know the equation of motion, that is v square minus u square equal to 2as. So just put the values, v square, it will be 80 square minus u square, that is 60 square divided by 2a equal to s. So just taking the square, you will be get 6400 minus 3600 divided by 2a. So solving this, you will be get s equal to 1400 divided by a. So the middle point of the train has to cover a distance s by 2, which is equal to 700 by a. So v square minus u square equal to 2as. So it will be v square minus 60 square equal to 2a into 700 divided by a equal to 1400. So v square equal to 1400 plus 3600. So taking the square root, you will be get 70.7 km per hour. Alright, so this is our correct answer. So the important point here is this: just using the formula, the remaining terms is only calculations. Alright, so you need to build your mathematical concepts that is used in these questions and take and use the derivations, or we can say calculations part. All right, clear? Yes or no? Everyone, any doubt? Thank you for your attention. I hope today's lecture is helpful for you. All right. So if you have any doubt, so uh, please ask in chat box, and if you have time, then you also ask in doubt session. All right. So thank you for your attention. Uh, now we will meet in next lecture, and we will learn their law motion in a plane. Okay. So and give DPP on regular basis. Thank you.